Oh, hey, hi everyone. So I'm going to create a series of long form video on Python, basics of Python in data science. And we are going to start from the very basic, covering all the important chapters. And I'm using Jupyter Notebooks. If you don't know, it's a markdown notebook where you can put the text and code and run both at the same time. It makes the notebook more accessible, easier to manage. That's why I'm using Jupyter Notebook. Uh, so we will go chapter wise. The first is starting from the beginning, which is introduction to Python. Then we will go to intermediate Python and then advanced Python. So this will be a long video, and you can learn with me and apply the concepts if you want. So the first concept of Python is print. Print is very simple. So in other languages, you have if you want to print or display something in the user screen, then you use the print function. All the programming languages have this print function, although the syntax or the coding schemes are different. Now, the first point here is numbers are considered as numerical values solely when presented without apostrophe or quotation marks. So anything which is in quotation mark is considered as string. Uh, and without the quotation mark will be considered as a numerical value, a number. So when we will go deeper into the variables and types of variables, then you will have better understanding of what is strings or what is integer, float, and all those values. Um, to print anything, we use round brackets and comma is employed to distinguish between string or variable. So let's see, let's run it one after the other. Do you know what? I am going to run. Let's first print. Uh, so I have used hashtag to comment this line code and this as well. So when I put comment, this gets ignored by the system. So only the first line is getting printed in this case. So you get hello world. Why? Because you have double quotation and then the string or the words or the sentences are written inside these quotation marks. Let's say if I use a single quotation, will it work or not? Do you know what? Do you want? I will remove this hashtag and let's check. Okay, so even if you put a single quotation, you will still get the result, or you will still get the printing of these words. Now let's assume you have multiple words and you want to print it. You can use comma separator. So you're using comma, and then this is considered one. This is considered two and three. Everything um, is joined and presented in this print function. And the very last one is printing a number. So if you check, we are not going to print uh, a string, but instead we are printing a number. Let's say, let's just for your curiosity, I am going to put this in string. Now this is string. This is considered as a character. Still it prints as 10, but now this has given by putting quotation mark, I have given it a new context, a completely different one from the uh, previous instance where I did not use quotation marks. So if I remove quotation, now it's not a string anymore. It means it's not a character anymore. It's a number, and I get the number as 10. So this was the very basic first concept. Now you have seen these values right inside the print function. You have seen there is a number, there is a string. But sometimes we are going here. It's only one string, or here there is only one number. But let's say if we are dealing with multiple numbers or multiple strings, or maybe the combination of two. In those cases, we need to assign that number or that string with a variable. So basically, a variable is a named location in memory used to store data. So variables act as a container, a holding value, and you can reference and manipulate these values using a variable name. So it's basically a placeholder, and that placeholder is dynamic. So let's go to its properties. So no explicit declaration. In some languages, you have to put, let's say, if you're assigning uh, an integer value, then you put int, then give the name of the variable, and then assign its value. In Python, you don't have to do that. You just Python variables do not require explicit declaration. So nothing like, as I said, nothing like int x or int a. They are created when first assigned. You put the variable name and you assign the value. The computer itself understand that this value is either a string or a number or a float. The second point is dynamic typing. So a variable can hold any type of data. That's why it's dynamic. You don't have because you don't have to do explicit declaration. The computer understands the variable type and by the value that you put inside that placeholder or variable. So that's why it's dynamic. Then you have a case sensitive. Uh, you have case sensitive variables, and they could mean completely different things. So if you put age, okay, hold on. If you put age and with uppercase or lowercase or maybe all uppercase, then these two are different. These three are actually a different variable. So it's case sensitive. Variables are case sensitive. Must start with a letter or underscore. So it's not exactly a rule, but it's a good coding practice. So variable names can include letters, numbers, and underscores, but cannot start with a number. So it has to start with the variable with any string of any character, but it cannot start with a number. It can also have underscores. So let's start with this one. Okay. So what this is showing you is the variable itself is dynamic and mutable. What mutable means is it you have once assigned a value to a variable, you can change it in later times. So for example, initially the assigning values, so we assign values to variable. We define a name, we put the name as Alice, and that's a string. Again, it understands it's string because it's put in the quotation mark, and without quotation, it becomes if there's a number, it is considered a number, like in age. In height, again, this is a float value. Float is basically a decimal value. So you have decimal here, 5.9. Is student true? So when there's true or false, that variable automatically becomes a Boolean type. So you have Boolean value as well. Again, now what you did is you are changing variable values. As I said, it's mutable, means initially we started with the value of age as 25. Now we are changing it. Once we changed it, it becomes age is now 26. The name has also changed from Alice to Bob. So we've changed the name and the variable of name and variable of age. And now let's say if we using variables to print, um, okay, so if you have two variables, you can do any type of arithmetic operations. So here we did sum, and uh, you got the values. Now, if you see, we have done a lot of assignments and one operation. So these are variable assignments. We have defined a variable, given the name, and here we did one operation as well, where we did the summation of two variables. But we didn't print anything, and because we didn't print anything, these values are not displayed. So what is displayed? Bob and 26. And why that's the case? Because the print function has only been called twice, once for name and the next was for age. So when we did name and age, so here is Bob, here is his age is 26, and that's why we get the values. If you see, the print name is not taking the value of Alice because this has been changed. As I said, the once you rename a variable, the old value gets omitted. So here his age is not 25, but instead 26. Okay? Yeah. Next is input command. So in these assignments, you are seeing that we are giving the values. We are predefining the variable name and also putting values for those variable names. But here, but that's not going to be the case every time, right? That's not going to be the case. So in other times, one other command comes in where we take the values from the user. And for that, we are using input command. So here we have print enter a number, and we have num int input. Okay, so okay. I'm going to run it and then explain. So the first line of this code command is print function enter a number. That's why it's printing enter a number. If I put, let's say, 2. Now where is this 2 getting stored? It's getting stored in this num variable. So So how is this defined? It's using an input method or input function, let's say. Input function. So input takes any values which you put using your keyboard. And because that value is not integer, and I said this has to be integer because we are asking the user to put a number. And that's why when you do input, input takes any character, any string, anything, right? And that object can be anything. So we have to convert that to an integer, and that's why we are using integer function to convert the input that you're receiving from the user. Once that's done, it gets stored in num, and then finally it gets printed out. Uh, so if I do two and and then do enter, I get two. So first, what happened was enter a number, print function. Then inside, I put an input command. Sorry, I did an input command where I took users input, but because I was very specific that the variable has to contain the numerical values, I converted it using in function. So just remember these two functions. It will come in handy in later on exercises. So we put number print, and then we got number two and two. Okay, uh, let's check another code. Likewise, so sure, in the previous code block, you were seeing that we have put three commands to get what we wanted, right? In this case, we are doing and placing everything in just one single line, just to make things less cluttery. So we directly define a variable. We know we wanted a variable age, and age is going to take a numerical value. So first we did was input, and instead, look here we printed the first line, which is enter a number. Here, because this is a function, and inside the parentheses, it can take arguments. So here in the input function, we are giving an argument that enter your age directly into the input function. You can do that. Now, this again becomes an argument. In this case, it's not an argument, but you are getting a value from the user. So that input gets changed by this in function, class int. So this converts whatever you are getting from the user into the integer, and that gets stored in age. So let's say my age is 18. I put enter, and it says enter your age, and it gets stored. Again, this is not printed. So what is printed here is enter your age, right? And then you did the colon, and then when you put the value age, it gives you the value 18. So that's just another way of presenting this code block into this form. I hope that makes sense. Now moving ahead with our new chapter, which is data types. So we have seen variable, right? Variable has there are different types of variables. So we have int, integer, we have string, we have float, we have boolean. That's exactly what we are going to study here. So what are different types of data which get stored in a variable? So data type defines the kind of value a variable can hold, and the operations that can be performed on it. So Python is dynamically typed, meaning you don't have to declare the type explicitly. The interpreter, I'm sorry, yeah, the interpreter infers it at real time. Okay, that's straightforward. We have discussed this before. So these are the types of data that we have. So we have numeric type, we have sequence type, we have set type, we have, okay, I'm sorry. We have set type, and then we have, okay, just give me a minute. Yeah. So we have set type, we have Boolean type, we have binary types, and non-type. So we are going to go um, to each of these. So first is numeric types. So numeric is very straightforward. So you have int, again, an integer value, simple integer value, 1, 2, 3, 4, and so on. Then we have float. These are decimal values. So anything beyond point will give you the decimal value. And that's called float in coding language. Then we have complex number. Now, complex number is it has a use case, but most likely it has use cases in engineering field. So just remember that it is a type of a numeric variable, right? It's a numeric data type. So so what happens? I'll give you a brief. So this is the real part. If you take the x and y axis in your math class, you have two-dimensional graph, right? So you have x and y. So this is 2 is the real value and 3 is the imaginary value. So in two-dimensional, there's a there is a a z axis. So z is the third dimension that we give, and and that's totally imaginary, and that value is going to be 3. So yeah, I mean, this is a complex number. If I get any questions, I will dive deeper into those questions to explain it better. But just remember that complex numbers are also numeric types. Then we have sequence. So we have seen numeric types, then comes sequence types. So these are ordered collections of items. So what can possibly come in this? So we have 3 types here: string, list, tuples. Okay, so string, as you know, is anything inside the quotation marks. It has characters, alphabets, right? And that becomes string. It's not mutable, so the text cannot be changed. Okay, so and then comes the list. So in list we have um, it's mutable. Okay, you know what? I will explain this concept of mutable in when we go deeper into the string part list and tuples, because then with solving the questions and problems, it gets easier to explain what mutable really means. But so far, just remember, a mutable means anything that can be changed. So here's the description. So a list 1, 2, 3, it's mutable, it's ordered, and it has changeable collections. So these numbers, these value points can be changed. Tuple is like list. It has ordered values, but it's unchangeable. It's not mutable. Then we have mapping type. So we have sequence type, then comes the mapping type. In mapping, there's only one, which is dictionary. So what does this mapping really mean? So in this, it has something called key value pairs. So there's one key, and it has the value. So you can put different types of strings, integers, different types of variables in one dictionary to define something. Let's say here this dictionary uh, is defining a student, the properties of a student. So student has a name, Alice, and her age is 25, and that is defining a person, right? So it has name, which is variable, and it across the classroom, everybody's going to have a name. So it's a key. And then every key has a value. Value is what goes inside that key, or how is that key defined? So name is going to store a name, and one such example is Alice. Likewise, age is again a key, and it holds the value of the person, a particular person, or in this case, it's going to hold a numeric value of age. It's not ordered. You can shift it however you want, and it's unordered, but it's mutable. So these key values can be changed. So one such example is here. You have person. So person again, it's a dictionary, right? It's a dictionary type. You have name as a string, okay, and then you gave the name variable a value which is Bob, and in the same dictionary you have age, and you give the age as 30. Once you print, so you see, okay, now you will see why dictionary is very important. Let's say you're storing multiple dictionary items, right? And you have to search, or you have to print a value of a particular variable, not the entire dictionary. And that's where the key value comes in. With the key, you can print the value, as they did here. So print, again, print function, person. So they have called in this dictionary person. And in that dictionary, you're using the square brackets. So you have to remember that to find the value, or the value of a key, you have to use this square brackets. And they are calling the name variable, the first key. With using the key, they're going to print the value, and that's what they did. They called the dictionary. They put the key, and with that they got the value, which is Bob. So I hope this makes sense. Then we have set type. It's again a very simple one. Set is unordered. It's not ordered. So far, you have seen only the less than tuple are ordered. Rest are all unordered. So you have set types there are set and frozen set. Frozen set we are going to see later on. Not right now. It's a complex topic. But let's say set is used often. So you have example 1, 2, 3. This is very different from the list. If you see the brackets, the type of brackets which are going to be used defines how a particular item group is either a list, tuple, or dictionary, or set. So everything here, the collections, either it's list, tuple, dictionary, or set, all have different brackets. So set uses curly brackets. Dictionary also uses curly brackets, but again, dictionary has key value pairs. This has single values. It's again mutable. List is not mutable. Set is mutable, and duplicates are not allowed. So if you have set unique numbers as 1, 2, 2, 3, the set is only going to print and in fact store the unique numbers. It's not going to store all the values. So once I print, you will see. Okay, you will not see because it's not printed. I'm not printing anything, right? So I am going to do unique numbers. Yeah. And now let's see what's the print. It is going to print 1, 2, 3. Okay. Because of these curly brackets, the computer knows that this variable is a set type, right? Now let's change the curly brackets to normal parentheses, open and close. Now let's see what happens. So with set, we are seeing that we are only getting the unique values in 1, 2, 2, 3. We are only getting 1, 2, 3. Now, if I print this value again, let's see what we get. We get all the values. You know why? Because duplicates are allowed in list, but not in set. And that's why it's important to remember what type of brackets you are using. So every bracket will define the unique collection, the collection you are going to use, either set, list, the unique data type you are going to use, either set, dictionary, list, tuple, anything, right? Okay. Now, let's go ahead and check the Boolean type. In Boolean type, so it refers, it's a very simple one. So this data type only holds two values. One is true or false. So if I print this, you will say is active, it's true, is admin, is false. We have defined it. If I print, let's just print it to see what value we get, right? Okay, let's just print it. As you see, we have stored true to this. It's hard coded, which means we have already defined it. It's true. When we print it, it gives you the true. And the very last we have none type. None is very simple. Anything which does not hold any value in that placeholder or variable that is considered a none. Or you can define as well. So let's just print here. Print results. This is going to give you none, right? So it's not going to store anything. So it just gives you none. Okay, remember one thing. You're seeing none and you're seeing none here. And you might be thinking, okay, maybe this is just a string. No, this is not a string. Okay, and we will in the next chapter when we discuss what the data types that how we are going to check it, what data type is for a particular variable, then you will understand more. But let's say if I put string, this will also give you the string value none, but the type will be very different, and we are going to see in the next chapter what I'm going to what I'm saying here. But just remember, this is a completely different variable type. Okay. Uh, so next we are going to study the topic of checking the data types. So far we have seen what are different data types that are present in Python. Now let's say if I gave an example where I used this none data type, but in this case, this is a none type, right? But let's say, and when I printed it, I got the result none. Well, let's say if I do if I put the string or quotation marks and then I print it, you will see I will still get none as the output. But this none and the previous output were totally different. So this is exactly what we are going to learn in this section where we will check the data types that we have. So we are going to use type function to determine what type of data, type of variable is defined in a given code. So for example, we have excess 10. Now, when we print normal x, you will get the value 10, right? But now because we are finding the class or the type of variable that we are using here of this x, so when we do type x, we got int. So let me run it. Okay, so it's int. Let's say if I put something else, you have to find other as well, right? So just say hello. What do you think this will give out as an output? So here the output will change from int to string because it's a string, str. Let's take another one. Let's take something more difficult one, which is not exactly difficult, but a different one. So now we are using decimal value. So it should give you float. And there you go. You got float as an output, right? And now let's go back to our previous example of none. As I said here, it's a none type data type, right? But let's just find what's the type to be W short. So I'm just going to use type function here. Okay, all right, one more brackets. And when I do, you see I got none type. Well, let's just put string here. String, let's define this value as string by putting a quotation mark, and then this will become none, right? It's none, but not it's now this will not be a none type data type, but a none as a string. You see? So this is how we find out the data type using type function. Again, you can use type to find list, dictionary, set, byte, array. Okay. In this, they are also explaining what's mutable, what's immutable, what's dynamic typing. So mutable is anything which can change. The values inside it can change. So list is one, dictionary, set, byte, array. So these are all mutable. Now, immutable are those data types that cannot be changed. So int cannot be changed. Once you define it, you have to redefine by calling the original variable name, right? So inside it, you cannot change. Then we have float, string, tuple, frozen set, bytes, and all these are immutable. Dynamic typing is another one. It's a property. So these are properties of different types of data type. And then we have dynamic typing. In this, a variable can change its type. So you can give any data type. So you have initially given, you have defined the data type for a variable, and you have given the value. But then using dynamic typing, you can you can convert that data type into some other data type of your wish. Okay, now we go ahead to another very important chapter, which is operators and expressions. So we have seen data types, we have seen how to take an input, we have seen what are some different types of data types that we have, how to find what's the type of that data type, right? But we are not going to do operations which are important. So operators are special symbols that perform operations on variables and values, while expressions are combinations of variables, operators, and values that produce a result. It's pretty straightforward. So one such operator is very common. You have studied in your basic mathematics class as well, which is arithmetic operators. In arithmetic operators, you have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. Some examples are there. Addition is pretty straightforward. 5 plus 3 is 8. Subtraction is also pretty straightforward. 5 minus 3 is 2. Multiplication again. Division. Everything, the top four are pretty clear. Everybody knows about this. Then we have something called modulus. Now in modulus, when you divide something, when you divide an integer by another integer, you get the remainder, not the answer, but the remainder after dividing the original value by something. So 5 and 2, if you see 5 upon 2 is not fully divisible. 5 is not fully divisible by 2. Obviously, it's going to leave a remainder, and the remainder is 1. So modulus always gives remainder value. Then we have exponentiation, or finding exponents. It's pretty straightforward. Other programming languages use pigeon hat to give the exponent value, but here we're using double star. So if you do 2 star star 3, you get 8. The same thing as 2 raised to power 3. It's the same thing, right? Then we have floor division. Now, when you do floor division, you are going to get the divisor, the nearest divisor, with which you will get the lowest remainder. So for example, 5 over 2, you do it, you get what's the closest number that you are going to achieve while dividing 2, while dividing 5 with 2. You're going to get 4, right? And how you're going to do it when you multiply 2 times 2. And that's why you get 4 and you get remainder as 1. So that's why you see floor division gives you the closest divisor, and modulus gives you the remainder after you have gone to the closest number to that original value with which you're dividing, right? Let's take some examples. Examples are pretty straightforward. Okay, so we have defined a variable with int data type. It's automatically int because you have given a numeric value. Likewise, b is 3. When you add these two numbers, it's a summation that gives you a value of 13, right? When you exponentiation, that's 10 to the power of 10 raised to 3, that gives you 1,000. And then you go ahead and do floor division. What's the closest that you can get when 10 is divided by 3? You get 9, right? And how do you get 9? When you multiply this b times the 3, you get 9. And that's why you got 3. Let's take another one. Print. Let's get the modulus as well. So I'm going to do modulus b. Let's give some space here. Yeah. This is going to give you the remainder. So if I do the shift enter again to run the code, you see we got the closest divisor, which is 3. And when you do 3 times 3, that gives you the closest value to 10, which is 9, and then you get the remainder, which is 1. So I hope this is clear. We're going to see comparison table next. Okay, so far we have seen the arithmetic operators. We have seen different mathematical operations which can be performed in Python, which these are additions, subtraction, multiplication, division, modulus, exponentiation, and floor division. Now there are those are called arithmetic operators. The second is when we have to do comparison, or we have to find the relationship between two variables, or let's say two values. So these are called comparison operators. And these include equal, not equal, greater than, less than, greater than or equal, or less than or equal. These are all very straightforward. Let's say if you have to, the only thing you might not know, or maybe the symbols are not familiar, would be in the case of equal to and not equal. So an equal to, when you're comparing two variables and you need to find out if these two are equals, you put double equal sign. And why is that? Because if you put the single sign, it's an assignment operator. So let's say at the bottom you see x equals 10. This is not comparison. This is assignment. You are assigning a value to this variable. But let's say if you had to equate or find if the two variables are equal or not, in those cases, you are going to put a double equal sign, and that compares. If this is true, then the result will be either true or false. So in comparison or in relations operators, the output is always going to be true or false. So first we have seen arithmetic operators, then second we have seen comparison operators. Next are going to be logical operators. So the logical operators are pretty straightforward, and they are and or not. So let's say if two conditions are true, then we have and. So for example, 5 is greater than 3. The first condition is right. 5 is indeed greater than 3. And 5 is less than 10. And in this case as well, 5 is less than 10, 10 is bigger. Both two conditions are correct, and that's why you get the final result as true. Now what if the at least one condition, so only one condition is true. So you have 5 greater than 3. That's all right. That's a correct statement. But the second one, 5 is less than 2, is incorrect. And that's why you have only one option correct. And this gives you a true value. So at least one is correct. When you put not, so it completely reverses the result. So let's say 5 equals 2. That's a true statement, right? This number is, the two numbers right here are equal. But once you put not, then it becomes false. It just takes the opposite of the original result. Then we have this code. Let's run it to see. Okay, so you have assigned, hold on, yeah, here it is. So if you have assigned an age, the age is 25, and we have also assigned Boolean. So the first is the numerical type, the int. Second is Boolean type, and we have defined the Boolean value as true. So first statement that we have inside print function is age is greater than 18, which is true. Excuse me. And is student. So 25 is greater than 18. That's correct. The first statement is correct. And is student. So this value is true. Both of these conditions are true. That's why the output that you have received is true. In the second one, we know is student is true, but now because we have put not in front of it, then we are going to get false. Initially it was true, not just makes the results opposite of the original, so that's why we have false. And so we have seen how many types we have seen. We have seen arithmetic operators, we have seen comparison operators, we've seen logical operators, and now next we are going to see assignment operators. The first assignment operator you have been using for very long, right? So initially at the beginning of this tutorial, we have seen everything that we are assigning, every variable which was defined was given a value, and that value was given through assignment operator, right? Which is equal. So we have the first variable x, and you have given the assignment as 5. So you have assigned the value of 5 to x. The second is plus equal. This is a new one. So
Only the first one would seem like familiar to you. The rest all are very new. So once you have x equals 5, you get 5, right? But the second one, x plus equals 3, this becomes x. You have original value. What you are going to do is you add 3 to the original value, and then you're going to add the new value. I'm sorry, you're going to assign the new value to original variable. So in this case, let's say if you had x is 5, right? And then you do x plus 1 plus equals 3. That means original value of x, which is 5, is getting added with 3 more. Is getting added with the number 3. So the new value is going to be 8. And 8 will be the new assigned value for the variable x, right? Likewise, we have minus equal. So what it does, it subtracts 2 from the original value and then assigns the new value to the variable. Likewise, we have multiplication. You multiply and then assign a new value. Division, same thing. You divide and give the new value. And then we have the modulus as well. Exponents, floor division, everything is going to be the same. So it's ideal we practice something. So if you assign the value 10, and if you are going to add 5, it gives you 15. And when you so the new value is going to be 15, right? Because x has been replaced with the new value, which is 15. Now this 15 is going to get multiplied by 2. So that gives you a new value, which is 30. You know what? Let's do one thing and let's add some more values. Let's do some more uh, assignment operations here. Let's do floor division as well, because floor divisions are important to understand. Let's do divide to 2. Let's see what we get. We get 15.0. And you know what? Let's see the type as well. So what is the type of this variable? And if I do the typing, I get a float value. Interesting. So when I am dividing an integer, let's see what's obviously the original x was integer, but when I divide something, then I get a float value, not an integer value. To test that, let's just divide. Let's just put hashtag on all of the other values. I think this will also be a lesson for you to understand. Oh, I'm sorry, to understand that how things are defined in Python. So what I did here, I put comments on all of the other code, and we only have the original one, which is x equals 10. Now, if I'm checking the type of this function, this variable, I'm getting int. So it initially started with int. Now, in the second line of code, I am going to test. Again, it's 15, and 15 is an integer. So when you're doing addition, you're getting integer values. How about if we do multiplication? So if I do multiplication, again, I'm getting integer value. Let's see what happens when I do division. Things gets changed. So once I once I did division, I got a float value. So this is something you have to remember, that when you're dividing something, the final result will be a float value, and here the float value is 15. And let's do something. Let's also do exponent modulus. Yeah, we forgot to do modulus as well. So modulus is going to be division equals 2. Let's see what we get here. We're getting 1. Why 1? Because 15, when it gets divided by 2, gives the nearest divisor. Oh no, the nearest dividend is 14. Yeah, so the nearest one is dividend is 7. That gives you a value of 14, and the remainder is 1. Okay, so x is now 1. Okay, you know what, I have to do a floor division as well. So I'm going to multiply it just to bring the original value back. 15, yeah. Okay. Next, I'm going to do floor division. So floor division by 2. Let's see what we get. We are getting 7. Again, it's very simple. So the nearest divisor was 7. 7 to 14. 14 is the nearest number that we can achieve when dividing it by 15. So that's why it's 7. Okay. I think things are now clear. We can move ahead with the next type of operator, which is membership operator. So we have seen a few data types, which were list, tuple, and dictionary, right? And set as well. So in these types of data, we often have multiple values inside parentheses. If you remember, list has brackets, and inside the brackets you have multiple values, right? And to find a particular value, or maybe to confirm that if a value exists in that list, or maybe in tuple, or inside the data type, we use two operators. One is in and another is not in. So in gives you true value again, like we have seen before, and or not operator, the results or the output is true or false, the Boolean value. So when you do in or not in operator, in gives you true value if it exists, and if it doesn't exist, not in returns true if the value does not exist. Okay. So A in apple. So if you have one string apple and you're finding if the character A is inside apple, which is true. Again, this is true. 10 not in 1, 2, 3. So we have one list, 1, 2, 3, and 10 is not there. So if 10 is not there, that's true. Again, it's a true. So if we see an example, fruits. So we have defined a list type of fruits. You know what? Let's do something before doing any type of coding, right? Let's put comment to test something. Let's say we are given this data type and we don't know the type, either it's list, set, because you know if you remember my previous lecture where I said brackets define the data type, right? So we have curly brackets, we have full brackets, we have normal parentheses. So to confirm, what I'm going to do is print type and put, let's see what we get here. Okay, so it's confirmed it's a list. So what we are seeing here is list, and starting with parentheses is an indication that it is a list. So this is a list. Now I'm going to comment this out using hashtag and use this one. So now we know we have a list called fruits. It has 3 elements. Those 3 elements are again string, right? And we are going to find out if this string element is present in this list. So here we did banana in fruits. So banana is present in fruits. That's why the output is going to be true. So let's just print. Let's see if that's true. It's true. The second option that we have, the second value, or let's say just second string that you're going to compare and find out, mango is not in fruits. So we are seeing mango is not there. So not in fruits is true when the element is not in list, which is true again. So this will also result in true value. So the next operator is identity operator. So it is used to check if two variables refer to the same object or memory location. So again, like we have seen before, here when we were finding the if a given element or if a given value is the element of a list, tuple, or a dictionary. Likewise, we are going to find if there are two operators here as well, which again gives you the output of true or false. So first is. So it's true if both both variables have same memory location or same values, and is not gives you true if x is not y. Okay, it's pretty straightforward. So in or not in is there to check if the object, or let's say if the value exists in the sequence type, and if the is and is not is to check if the two variables are somewhat similar, somewhat not exactly similar. That's right. Yeah. So we have an example here. We have a list defined, and we are also saying b is equal to a. So it's referring to the same object as a. So we have some values in a, which is part of the list, and that list is also getting referred to another variable b. Now c is a new object, and it also has the same name as a, same values as a. But we have to check if a equals b equals c, because if you see, logically speaking, you will see that a and b should be same because they are referring to one single list, and c is also exactly the same as a. That's why c should also be equal to b. That's what we are going to check. Let me comment out the second print function. Check the first one, which is print a is b. If we run this, we get a value true. Okay, so a is b. This is this is true because a is the list. This is true because a is a list, and that list is getting referred to b. It has same memory. Okay, now let's check if a is also equal to c, and this is false. The reason why it's false is although the elements are same, so both are lists, both have same values, but they have different memory location. Those two are not exactly the same, and that's why a and c are not equal. So, so far we have seen various operators, all right, and now we are going to see various expressions in Python. So an expression is a combination of values, variables, and operators that evaluates to a result. And this we can only understand. So when you have combination of values as well, variables, and various operators, all the six operators we have seen before, let's do a recap to understand what operators we had. The first was arithmetic operator. Second was comparison or relation operators. Then we had logical operators. Then we had assignment operators. Then we had membership operators. Then we had identity operators. So there were six operators that you have to remember. And finally, we have expressions. Expressions, a combination of values, variables, and operators. And okay, so this has four parts. This code block has four parts. The first is defining the variable. So we have taken a variable age. It's an int type, and it has value 20. And has licensed it's another variable type, variable, and the type here is true, which means it's a Boolean type, Boolean. And finally, we have a list. So we have defined three variables. One is int, the second is Boolean, and third is a list. Then what we are going to do is do various types of expressions. So first is arithmetic expression. So we are going to use multiple operators at once to create an expression. Again, we have defined a variable name, result. In this, we are going to do this calculation using mathematical or arithmetic operators. We're going to print out the value, which means we're going to give the result and print the result here, right? It's this was simple arithmetic expression. Next, we have logical expression. So in this, we are going to see if it's a so logical means true or false. So its value is a variable, and it has two statements, and we are going to find out if it's true or not. So first is age is greater than 18. So age we know is 20. Obviously, it's greater. So the first statement is correct, and means if first is true, the second has to be true to get an overall output of true. Second is has license equals true, and this is also true. Yes. And that's why, because both of these statements are true, we are going to get an output of true, which will get printed. And finally, we have membership expression. So the first is present. We have defined a variable name, and we are going to find if this particular string is present in fruits list. So again, it's true because it's present. So if we run the code, we are going to get the values. Arithmetic result 16. Yeah, because if you do the calculation here, like plus 3 is 8 times 2 is 16. Is valid. Both these statements, age greater than 18 and has license true, both are true. And if both are true, the logical expression's final logical expression is obviously true. Then we have membership expression apple in fruits. This is again true. We have found apple in this list, and that's why this is true. So you can see we used, this is the final summary. So we have arithmetic operators, plus minus, times, division, modulus, exponentiation, floor division to perform math operations. Then we have comparison operators. So this is equal equals to, which means compare if two variables are same or not. Not equal, greater, less, greater than or equal, less than or equal. So the comparison operators give the values true or false. Again, logical operator and or not, these also give true and false. And then the fourth one is assignment operator. So we are going to assign to modify variables. Pretty straightforward here. Then we have membership operators. And next we are going to find if a given variable is part of the elements in a list or any sequence type, either it's list, dictionary, tuple, set, etc. And finally, we have identity operators to understand if two variables point to the same object or same memory location. So this last one will be the most important one in my opinion. So I think we are done with the operators, expressions, and now we're going to strings. So I think this will be a good time for you to take pause, probably recap, do a summary of revision to see what we have covered so far. Chapter that we have here is strings. So strings in Python. So a string or a shorthand name is str is a sequence of characters enclosed in code. So strings are immutable, cannot be changed after creation, and support various operations like slicing, concatenation, and formatting. We have seen strings before as well when you are using single quotes or double quotes or in some cases, if you're using multiple lines to create sentences, in those sentences, you were using single quotes, double quotes, or triple quotes. These are all strings. The first block of code is pretty straightforward. We have string as hello using single quotes, double quotes, likewise. And then we have triple quotes string. Do you know what? Let's do one thing. Let's print out the last one because we have not seen this before. So we are going to do string print of the last one to see how it looks after it gets printed. So it gets printed like it's displayed. So it's multi line, and the first line has three. And this is A, and the second line has multi-line string. Okay, so this is exactly how it looks in the code, and this is also how it's displayed in the execution block. We now know how to create a strings. The second is we have to do something about strings, and those are done using string operators. We have some of these which we are going to look. The first is concatenations, joining two strings. If you remember, we did this. Not exactly concatenation, but joining two strings in the very first exercise where we were printing string. So we had a print function. And inside the print function, we were using comma to add multiple strings, right? So that was one way to do it. The second is, let's say we have two variables defined. The first is first name, second is last name. And the full name is going to be the addition, or not exactly addition, but the joining of first name and second name. So we did the first name and we did the second name. Now the question that rises is why we have a blank string in between. This is to give space. Let's say if we remove this and just print without giving the name, without giving the space, this is how it will look like. There's no space. We need to give another some space in between two words, and that is done by defining an object, a string object, likewise. So if we print, we get John Doe. I think this is pretty understandable, right? Next is repetition. So we have to repeat the string multiple times. So here we have defined a variable greet. We have a string, and that gets repeated 3 times because it's multiplied 3. Not exactly multiplied, but yeah, it gives 3 outputs. Once we print greet, we get hi, hi, hi. So I don't know if this is used in there is not a diverse application for this operator, but it's good to know. The other important is indexing. I think this is the most important one, if you ask me. So you want to access, so if you had to access an element in, let's say, a sequence type, for example, list, you were using in operator, right? So in string, we define a variable, we put the value of string, and each alphabet denotes or references to a particular numerical block. So it starts from 0. So the first placeholder is 0. The second placeholder is 1, 2, 3, and 4, so on. So when we print the first placeholder, again, it's a placeholder. You can put any values in it. Here it happens to be p. So when we are printing text 0, the first element or the first placeholder, we are getting characters p. And if you're doing -1, so what does minus mean? Minus means it starts from the back. So the last character will get printed. And let's say minus is the same as if you are doing the front. If you're moving from the front or moving from the back, it's the same thing, right? So 0, 1, 2, 3, 4, 5. If I do text 5, this will give the same value as -1. Let's run it. So you see, it's the same thing. Minus means it starts from backwards. Plus means it starts from the left-hand side. Another important one is slicing. So slicing has 3 steps to it. So it extracts, if you're using indexing, it is giving you a single placeholder, right? But if you have to find different values for multiple placeholders, then you are going to slice. As the name suggests, you have a string and you're slicing something out of that string. So it extracts a substring. In this case, we have a text hello world. Now we have print text 0 to 5. So it starts from 0, 0, 1, 2, 3, 4, 5. It will give you the value of hello, but it's not going to give you the last one. So in slicing, what happens? It it considers the first, um, so it considers the start, but the last value, where it has to stop, it gives you the value before that. So let's say if you are putting the number 5 here, it's going to stop at 4. So it's 5 minus 1. So it starts with 0, 1, 2, 3, and 4. And that's why you will get a print hello. The second is text 6. It starts from 6. So what is 6? 1, 2, 3, 4, 5, 6. So it starts with sixth one here. And then
ends with well, practically it doesn't end anywhere. It ends with the sentence itself or the word itself, the string word itself. So let's say if I had something else here, words. So okay, if we print exactly this, it starts with sixth character and then prints to the very end. So six is included: 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, and 6. The This is also considered one placeholder. Although it's blank, it means space, but it's still a placeholder. So fifth is not. Fifth is blank, and then you start with sixth. Sixth is included, and it goes to the very end, which is world. If let's say I put s words and rerun this code, you will see words. So whatever is the very last character in the string will also be considered. Okay, just to show you that the space is also a placeholder, I'm going to start this from fifth element, fifth placeholder, not the sixth. So if I rerun this, you will see there will also be a space. So you see an indentation here, so there's a space. Fifth is also considered, and sixth, and so on. Let's just leave it at sixth. So the word starts with sixth character and goes to the very end. Okay, next we are going to use the three-step approach, three-step slicing. So in this, you are seeing only two steps. So we have 0, 5, and the increment. So start is 0, stop is 5, but you will ask what is step. In this, default step is 1. So it is doing the incrementing it with one value. So 0, 1, 2, 3, 4. Okay, but in this case, the first is blank. So blank means it will start from the first. So it will start from here, the very first element. And stop, again, there's no value. So by default, it considers that it's going to cover the entire string, which it is doing. And then in step, you will see that it will do an increment of 2. So it will start with 0, 0, 1. Okay. So it's obviously it will start with 0. So it prints out the very first letter. And then it takes two steps, 1 and 2. 0, 1, and 2. So it takes two steps, it prints L. Then again, it does two steps, 1, 2. So you get O. But again, it takes two steps. But now remember, space is also a placeholder. So this will also be considered a step. Okay. So 1 and 2. So that's why W is considered here. Then it does two more steps, 1, 2, R, 1, 2, D. That's it. And that's why you are seeing this substring where the increment, the start is from the very beginning, the end is at the very end, and the steps of increment is 2. I hope that makes sense. Moving ahead, we have string methods. So Python provides a built-in method. As you have seen, we have to convert an input from the user to an int type. By default, the number is string, right? So if you have to, or maybe it could be a float. If you have to convert that to int, you were using a built-in function of int. That's why here we are going to use a function of string method, different built-in methods provided by string. You have to remember these syntaxes. I think it's pretty straightforward and very easy. So string.upper, when you do dot upper, so methods usually start with dot, and dot upper will give you all upper cases, dot lower will give you all lower cases, dot strip will remove deleting and trailing white space. So if you see there's a space, then high, then space. So if you strip, so the first space and the last one goes off, and you get a clean running word, right? If you do split, it's going to split based off the separator. So it splits. So for example, you have ABC three letters in a string, and you're going to split, and the split denominator is comma. So where there's a comma, it will take that. If it will take a letter before that and convert it into a different string. So this is considered one string, right? But when you do a split, each individual letter here will be a unique string. So ABC is a unique one. Then we have replace. So it replaces the substring. So if you do hello.replace, you replace H with J. So H is what we have, and J is what we are going to replace it with. So hello becomes jello. Then we have join again. That says it's like concatenation, but now you have a method. So comma is one, and you do a join. So in this split actually takes a string and splits into multiple substrings, right? Here we have multiple substrings in a list. If you see this particular case, it's the sequence. It's a sequence type, and in particular, it's a list type. We have A and B. When we joined using separator, this becomes one single string. So it's quite opposite of what split does. Okay. Then we have find. Find is indexing. So we were doing indexing, right? Index of here. We were doing indexing. Where did it go? Yeah, so first placeholder, second placeholder, third placeholder. Likewise, we can find a particular, so we have a string Python. If we do a Python and th,
we are going to find that its index is 2. TH. There are only 2 characters. That's why it gives 2. You know what? Let's try this. I think. Okay, anyways, let's first see the very last one, and then probably we'll try some of these methods. The string starts with check if a string starts with a substring. So we have hello dot sub starts with hey, and this is true. Out of all these methods, only this one gives you a true and false, a boolean return. Okay. Let's do this one. I was also confused, so I'm going to test. So we have text dot find, and our text was Python programming. So what we are going to do is Python programming. I'm going to find the index of PR right here. So if I do programming PR, let's comment everything out. I don't want any confusion. I just want to see the print of the very last command. So if I print, okay, okay. I'm sorry, it's not put in string. That's why it's giving the error. Let's try again. 9. Okay, so it's in the ninth position. Let's check how. What's the first placeholder? First placeholder, second placeholder, third placeholder. The third one gives you P. We can test it if you want. How? You ask print. We have text. What's the third placeholder? Let's print it up. Let's see what we get. We get Y. So we get 0. I'm sorry. 0, 1, 2, and 3. 3 starts with Y. So this is 2. This is 3, 4, 5, 6, 7. And then we have 8, 9. 9 starts with P. And that's why when we were finding using PR, the first character was P, and that was in the ninth position. That's why you got 9. Anyways, okay, I think this is clear now. Okay. I'm going to start with the first command that we did here. Print text.strip. What strip does is it strips the initial space and the trailing space. So this was the leading and trailing white spaces were removed. We got Python programming. Then what we did, we were seeing many uppercase. We did lower to put everything, every character in lower case. If we run this code, let's see what we get. We get Python programming. It's pretty straightforward. Then we were going to replace P with J. And now, if you remember, there are 2 P's. All of these P's will get replaced with J, capital or small. Let's see what happens. So J, capital J, and capital J. So uppercase both. Then we are going to take the next command, which is text.find PR. P was in the ninth position, as I said. I think we have discussed this before, right? And third was Y. Okay. In my opinion, this explains and probably should have given you more understanding of what we are doing here. Now let's see string formatting. So far we have seen string methods. We have seen string operations. There were concatenation, repetition, indexing. So our first topic was how to create strings, how to concatenate, repeat, find, index, slice. Then we have seen string methods, various methods that we have. Now we are going to format a string. And how we can do it, there are different methods of formatting. One is fstrings. This is for the latest Python version. So we have a variable name. It's a string type, and it's Alice. The age is defined here, which is 25. We are using f function. F function starts with f, the letter F. So print fstring. Sorry, not f function. Fstring. Fstring starts with letter F. My name is, and you have it's more. You see, string is more like a key value here, if you remember from the dictionary. It's something like that. So you have string, my name is, you put curly braces, and you give name. So it will take name from here, and I am age, curly braces. It refers, so when you put curly braces, it refers to the original variable, uh, variable from where this is defined. So it's defined here, and the original variable is name, original variable age, 25 years old. So when you give the output, you get my name is Alice, and I am 24. Now you will ask, why do I have to use this? I can, put name as well, and um, I can simply put name, right? But then if you will have to use multiple, there's another way. Okay, you know what? Let me do it. If I was not going to use f string, then it will be my name is my name. I'm sorry, my name is. Then I know this is not, this is a string, but I can't put it here, so I have to concatenate with name, and then do another one and do put another string. So you see there are multiple steps that I have to take, and I am plus age plus another string years old. I can't refer. I have to do this multiple times. If I do this, I think I did a mistake. Oh yeah, yeah, yeah. So I think this is a classic example. Now, f string is also very important. If you see this, I am, this gives an error because this is when we have to define a string. I'm glad we found this here only. Now, when you have to use apostrophe or quotation marks, single quotation marks, in those cases, it will give you an error because there are too many quotation marks for a string to be defined. So it's considering this as a string, then it is considering this as a string, but then it's confused. What is M here and why there are two quotation marks? That's why it's throwing an error. To rectify this problem, I can simply remove this and use the complete sentence. If I run this again, this, oh, yeah, I made another error here. So you see, it can concatenate string, but not int to string. What I did here was concatenate string, but then I am adding. So what I have to do is, just put comma here. You know what? I'm not going to concatenate anything. I'm just going to put comma. Let's see what happens now. Yeah, yeah. So concatenation only works on string. That's the another learning that I got with you guys right now. We can only concatenate string, not integer values. So unless we convert that integer value to string first. Anyways, so we have my name is and I am 25 years old. This also gives the output, but let's say in a case where I have to use apostrophe, or maybe there are multiple instances where you have to use apostrophe to create a meaningful sentence. In those cases, you cannot use um, this this type of code or this type of command. You have to use f string. I hope this helps in understanding why f string is important. Thank you so much. There is another way to format. So we have seen f strings to format a string, a sentence. There's another way. So when we use f string, we can put curly braces and call the original variable. In this, what we are going to do is use dot format method and do the exact same thing, but instead of putting the variable name inside the curly braces, we are going to use a method and then place the arguments inside that function. So if I run this, it gives you the same value. There is no difference. It's only different approach to solving the same problem. Okay, so our problem statement is how we can put apostrophe, how we can use apostrophe, single apostrophe, and still use quotation marks to define a string. That was our problem statement. Then we used normal normal f string to solve this problem. Another method is to convert everything into string. Now if you see here, everything is string, but now we have also formatted, so this apostrophe or single quotation gets it gets omitted. So we put the first curly brace takes the name variable, and the second takes the age variable, and that's why the final sentence here is my name is Alice and I am 25 years old. Okay. uh, the next type here is escape of characters. How we can break a sentence. In Java, if you have done, you know there is there's again an argument where you put break to break the sentences, right? Here as well, you can use sequences methods, sequence commands to break the sentence. So if you do backslash n, that breaks the sentence and puts the string in a new line. Backslash t gives a tab. Tab is a tab button in your on your keyboard, so it's the same button. Then you do backslash, double backslash. Uh, yeah, backslash will give you it gives a single line, slant line, and then we have a double quote. Then we have single quote. Let's print this to see what we can achieve. Let's just do the comment this command. Let's see the first command, which is print hello world. If I run this, you will see hello is printed in the first line, but then we are breaking this string into two different lines. So after doing slash n, it takes the next word, a word world in the second line. So you have hello world. Um, it's printing in two lines. Now let's see the second print command. So here you see he said, okay. So he said is there, comma is there, and then because you have to do quotation marks, right? And if you remember from the previous formatting, if you were using single quotation mark or double quotation marks, Yeah, the print command gets confused. If it's a string, what is it? Why are we using multiple quotation marks? So if we have to use quotation, we are using escape quotes. So for using double quotes, we did double slash double quote high, then again double quote slash. So it puts this word high in double quotation mark. Okay, I think that makes sense. Likewise, you can do single, single. So that's not different. I want to print this backslash. Okay, so let me just put he said, and then comma. We do backslash backslash. Yeah. So it prints double backslash. I get it. So this is used to print backslash because without it, you will have to use um, comma, right? And that I think will be difficult. So let's use different method to print backslash. If I do this, let's see if it prints. Yeah, it prints. But if I want to use everything in a single string without using comma, then I can print backslash backslash twice using the command, and it will print single backslash. Yeah, it's a escape character. Okay, that makes sense. Now we have string immutability. So strings cannot be modified after creation. So a new string has to be created. Yeah, we have seen this before as well. Integer and all those data types cannot be uh, mutated mm, or cannot be changed. We have text variable where we have put the value as Python. It's stored in text. And then we have new text where we are using J as the first letter, and we are concatenating it with the first letter of um, of this text, first placeholder, and it's going all the way to the end. There's no end to it. So start is one. So one means it starts with 0 and 1. So Y. So first character is J, second is Y, and rest as well because there's no end. So it creates a new string, and then when we print it, we get instead of Python, we are getting Jython. Yeah. So string immutability, mm, which again means string immutability means you cannot use this command. This command can be used to find. So if we do print text 0, let's just test this out. Text 0, you will see it will give you the letter P, right? But you cannot assign it. You can use it to find the index or the placement, but you cannot change anything using that the indexing command. So this was string immutability. In summary, we have seen strings are sequences of characters enclosed in quotes. Yeah, the quotes can be double, triple, single. Okay. Indexing and slicing. So in indexing, we are using single placeholders to find the value. In slicing, we are creating a substring using a start, stop, and step. Three parts to slicing is there. In methods, we are using different methods to something or format a string. So upper, lower, split, replace. Likewise. In split, you have to remember in splitting, you are using comma separated. You need to use a separator with which you are going to split a single string into multiple substrings. Yeah, and then we have strings. A string is the best to format when you have complex string or complex sentences. Escape characters are used to break a new line and do simple formatting like tabbing, indentation, adding backslash, or there was one adding double quotes, single quotes, likewise, right? Without confusing the computer. And then we have Python syntax and operators. These are explained. We have structured breakdown here. We have comments. We have seen comments. I have been commenting the previous code, but let's just see what are various options to comment. So far, you have seen only one, which is hashtag. If you put hashtag, then Python ignores that line. But what if we have to do multiple commenting that we are going to see later on? It's pretty simple. This is comment ignored by Python, so anything after hashtag is getting ignored. Nothing to explain here. It's pretty straightforward. Then we have shorthand assignment operators. We have seen these types of operators before as well in the arithmetic operations, if you remember, right? Very straightforward. I think this is just a revision. So plus and equal means it does the addition first, and then it equates the new value to the original variable. Same goes with minus equals, and multiplication times equals, and division equals. You can do same for a floor division, and you can also do the same for modulus, if you remember. So if you run this code, it's pretty simple. You have defined x as integer. It is carrying value 5, but then uh, you do addition of 3 to the original x value, and then assign the new value, which is 8, to x. Now, if you're going to print this, you will see it will print the new value, which is 8, not 5. See? It assigns. It does the mathematical operations and then it reassigns the value. Okay. Membership operator in. You have seen this. Again, it's a refresher. You have text. Python is awesome. You are going to see, again, membership operator gives you in, true or false. In this case, we are seeing Python is available in this long string, so it's printing out true. And then Java is false. So again, false, right? Then you have multi-line strings. So you are using triple quotes here. When you triple quotes uh, gives you multiple lines of code. We have seen this before, right? So you're using single quote, double quote, to triple quote. Triple quote is unique, where you will have multiple lines of string instead of everything in the single line. Okay, we have seen this before as well. I've escaped characters again, same thing. Um, Single line, this prints the new line, then tab does the indentation part. Backslash gives single slash. We have seen this double quote. If you have to put double quote, then you do use backslash to ignore the double quotes. Otherwise, the definition of string will get confused, right? It will confuse the system if you're using multiple quotation marks. And then we have chaining comparison operators. So here we are you doing multiple comparison. We have seen multiple comparison before as well, so it's just a refresher. You have x equals 5. Again, this is an assignment. X equals 5. Print. Now, x is greater than 1, which is true, but it's less than 10, which is true. So both the conditions are true. That's why the final output is going to be true. Yeah. So for again, simple summary comments. We are going to use single quotations for comments. Shorthand operators. This is going to simplify instead of using two lines to first one line to first do the arithmetic operations and the second line command or code to equate the new number. We can use simple shorthand operators to do two operations in a single command. In operator is again to find something in a list, not just list, in a sequence. Then we have multi-line strings to do multi-line printing. Escape characters is if you have to put something, format a string in unique ways, which otherwise would create confusion in a system. There you'll use escape characters, and then we have chaining comparisons where you are doing multiple comparisons in a single command. Okay, I think this is enough. Next up, we have some more conversion methods for string. We have seen lower, upper. The other one is capitalized. So in capitalized, you have all lower. Okay. What it does, it takes the first character and puts that in uppercase, and rest all are in lowercase. So that's capitalized. We have not seen that before. And comes the title. So in title, it takes, let's say if you have two words or three words, it takes the first letter of each word and puts that in uppercase. And that's why you have, uh, like here, you have Python methods, and it gets converted to Python and methods. Then we have swap case. We have seen this before. Swap case takes the Python. Let's say you have total swap cases of all characters. What it does is if there are lower cases, then those are converted to upper, and upper gets converted to lower cases. So these are different methods that are utilized. Okay. It is important to note that the original string remains unchanged because it's immutable. It's only when the method is called, it gets converted to, and that's stored in a new string, not the old one, because strings are immutable. Then we have case checking methods. So in this, we can check if all characters are in lower or upper, or if the first character in each string or word is capital or not, which means uppercase or not. So is lower, the results are in form of Boolean value. So is lower, let's say if everything Python, in this case, example Python, every character here is in lowercase. So the answer is true. Likewise, here everything is upper, so it's true. And the first character in both the words are upper, so it's true as well. And likewise, you have is lower is title. So yeah. Then we have character type checking methods. So we are going to see if all characters are digits, which means they are numerical values. If alpha means it's true if all the characters are alphabet, and is alnum, which means it's alphanumeric. This is used. You can understand these checking methods could be used in password authentication in various login portals, right? So where you have to put a new password and the computer asks you to put alphanumeric values. So let's say if you don't put that, it's going to use this method to find if you have put the right password or not. So everything is a number, is digit is true, true. If everything is in alphabet, it's true. If it's alphanumeric, then you have true as well. And then we have trimming methods. You can trim strings as well. So the first method is strip. So what strip does is it removes leading and trailing specified characters. If you remember on top, there was one method where you were going to remove the space, if you remember. So if you start with, yeah, this one. No, not this one. Sorry, I'm sorry. Where did it go? Yeah. Anyways, so what it does is strip does is it removes the leading and trailing specified characters. Anything before the desired string value gets removed. Anything before and after both. So strip removes the leading or trailing specified characters, a particular character. So in this, we know that there was dash dash and Python dash dash. We are stripping dash, so everything related to dash gets removed, and you have simple Python. And then we have lstrip. Lstrip, what it does, it removes dash, but it removes from the leading one. So it removes lstrip from the leading. And then we have rstrip. Rstrip removes the trailing character. Okay. So strip is for everything, L is for leading, or is for trailing. Okay. Yeah, I think this is straightforward. Then we have sort and replace. It's an important method. So it starts with is check if a string starts with substring. So Python is there, starts with py. Does this string starts with py, which is true in this case? So you get true. Ends with same, same logic here. If the given character or word, not character, sorry, word ends with on, then this will give you a true value, which is the case here. Then we have count. Count, what it does is counts how many times a character is repeated in a string. In this case, we have counting a in banana, and we get 3, right? And we have index. Index is very straightforward. This will give you the placement of the character or a substring. So you have python.indexth, and we want to know what's the placement of th. Indexing always starts with 0, so 0, 1, and 2. So t starts from 2, second place, so that's why it's 2. Third place, sorry, not second, but it's called 2. And then we have replace. Replace, what it does, it replaces, it takes 2 arguments. So first is what you are going to replace it, and with what you are going to replace it with. So we are going to replace L, and we are going to replace it with X. So that's why L becomes hexo. Now index raises, so caution is there, index raises value error if substring is missing. Hmm. Index value error if substring, yeah, it's straightforward. If you're not putting anything inside, then Python gets confused. What are you really finding out? What placeholder, for what character are you finding the placeholder for? That's why it gets confused and gives you an error. Next up, we have advanced string operators. Cipher example, so anything cryptography is is where you are going to use advanced string operators. Just note that here we are using advanced functions, loops. Just go through this with me, and then we will study for loops, while loops, and other stuffs in detail. It's just an example. So we have one variable where this strange looking string is stored, and then we have n as hello and t as blank. So for I in range, no, you know what? This is very fast. Let's not look at it just right now. So I'm going to leave it for now. Once we study 4, then we will come back here. Or maybe I should explain it. Yeah, let's just explain. So 4, take 4 has uh, two arguments. Okay, the first is your counter. It's called counter. It starts with 0. Ideally, it should start with 0, and then it's in. So I is what item is there? What item is present in the range or the character? So in this game, that's how for loops are designed. So it has a counter, then it finds that, not exactly counter. It starts with first placeholder. Initially, it starts from 0. Okay, so I starts from 0, and then it increments inside this range or the value. It could be anything. It can be list. It can be a string. Anything. Okay. So that's 4. Ideally, what it is used for is if we have to find it, and until we are not finding it, we are getting the output. Do you get it? So we have something, okay, and we are looking for something in something else. So we are looking for an element in let's say in a list, and we are running that loop until we find it. We are not going to stop. So that's what for loop is. So for I in range, and then length, this is again a function. So length finds it's it's a literal explanation, right? Length means how long it is. Length of n Let's see, what's length of n? It's 1, 2, 3, 4, and 5. Mm, do you know what? I am going to print this here as well for our understanding. Length n. Yeah. Just let's see. It gives, yeah, 5. So you have 1, 2, 3, 4, 5. So length is 5. For I in range, and here range is it's 5 here, 5. Okay. So range, what does range function mean? Range function starts. So if you say length is 5, so it starts from 0, 1, 2, 3, 4, 5. So that's the range. Range includes every possible values from the beginning till the end or the defined end. In this, the defined end is 5. So it starts from 0, 1, 2, 3, 4, 5. Right? Inside the loop, we have defined a shifted index. It's an int variable. Now, alpha dot index. Alpha is this variable, okay? And we are using index method because we want to count something. Index, if you remember here, it it finds the placement. So we want to find the placement of ni. I starts from 0. As I said, it starts from 0 and goes to whatever until it finds the object. So here, I starts from 0. So first is 0, n 0. So n here, 0 is h plus 1. Till now, okay, till here, 0 plus 1 means it takes one value. And then you find the modulus of 26. And why do we do modulus of 26? Because modulus of 26 handles z to a. So it's basically counting the characters. We have how many alphabets? 26, right? That's why. So we have shifted index and alpha dot index n1. Sorry, n0. So 0 character is here plus 1. Okay. So 0 character is what? H. But then we are finding e, right? E. So here we get e. Okay. You know what? Let me print this out because then it gets easier. Uh, print alpha. Let's see what we get. Alpha dot index, um, and then n I plus 1. We are going to do plus 1 first, and then without plus 1 as well to see what's the output. I made some error. What's the error? Yeah. I get it. The reason here is because why is it not printing is because this is integer, and I am taking. Well, I'm also confused. Yeah. So they have given an explanation here. Alpha index n1. This is straightforward. I starts from 0. So what is 0th placeholder in n? It is h, right? So you have h here. And then when you do plus 1, shift it to the next letter. The next letter is going to be e then. E, right? So this becomes alpha dot index e because this argument right here represents e. And because it's e, and uh, modulus 26 ensures wrapping from z to a. Yeah. It makes sense. And then this value, e, what's a placeholder of this e? Excuse me. 1, 0, 1, 2, 3, 4. So you have a fourth position. Index gives you fourth position here. It starts here, right? So fourth. The answer right here is 4. And you have shifted index value as 4 modulus 26. If I do 4 modulus 26, what do I get? Print 4 modulus 26. Okay, let's see. What's the print? Oh, I get 4. Yeah. And why is that? Because 26. Oh, it gives the remainder. Okay, I get it. Yeah. 26, 4 over 26 will give 4 as remainder because 26 times 2 is 26. Yeah. Okay. It gives a modulus of 4. And then we have t. T is first getting added to alpha shifted index, which is 4. So alpha 4 is 0, 1, 2, 3, 4, E. And t is getting added E. Oh, I have to check this code and require some editing. I don't know. Yeah, I'm not going to. Then we have case conversion. Case conversion gives you, we have seen this lower upper capitalized title will show swap cases. Then we have case checking: is lower, is upper, is title. Character check: is digit, is alpha, is elnum. Trimming: we can trip, strip, strip, leading strip, or trailing strip. Then we can search and replace: starts with, ends with, count, index, replace. I think this is very straightforward. This is a summary. It gives you all the methods that you can utilize to format a string. Okay. Then we have conditional statement in Python. So our next chapter is conditional statements in Python. So in this, we are going to learn about if, else, elif statements. So conditional statements allows your program to make decisions based on various conditions. So we have three such examples. There's if statement, else, and else if. So uh, it's as simple as an English word of if. If something is true, then do that. If something is not true, then don't do that. So it's executes a block of code only if the condition is true. Here's an example. Age is defined to be 18. If age is greater than or 18, then print you are an adult. So obviously age is equal to 18. This satisfies the condition, and you get this statement. In this, you just remember the syntax or the way the code is written for if statement. That's the only thing that you have to remember. You have to make sure that you are using um, you're using right indentation syntax. There are no mistakes. Okay. Next up is else statement. Again, uh, if something is, let's say if condition is true, then obviously it's pretty straightforward. You don't have to use else because it's going to print after it satisfies the if condition. But let's say if the if condition is not satisfied and the block of code is giving false result. In that case, you have to use else if. Oh, sorry, else, not else if. So I've defined age as 15 again. If age is greater or equal to 18, which is not true, age is exactly 15, which is less. So it is going to skip this print command and instead jump to the next code block, which is else. If this is not true, simply uh, print you are a minor. It's not going to print this one. It's going to print the next statement in else command. Okay. Then we have elif. Again, it's if so we have seen single conditions, right? If it's true, then print this. If it's not true, then use else and print something else. In this case, we are going to check multiple conditions in a sequence after the initial if. So let's say score is 75. If score is greater than or equal to 90, which is not true, right? So it's going to skip grade A. Then it's going to if you have put else, then the condition would have simply given you the result else, and it's you know what? Let's do it. I'm going to replace this else if and just print this. Let's see what you get. Okay, you're getting an error. The error is because okay, yeah, the error is because I'm using wrong statement. You have to remember the syntax, otherwise you will make the same mistake as I did. Yeah. So you know why this is not true? The reason because um, else the score is not taking the values. Let me go back to elif, and I'm going to print. Okay, let's just remove. Uh, yeah. The reason I'm not able to do else here is because I have to check multiple conditions. I have to assign a grade for this, right? In else, you cannot put condition, right? Yeah, so we are using else if to compare multiple conditions uh, and give the output which best satisfies the original statement, right? That's why else if is used. And let's say if none of these conditions are applicable, then we use a breaking statement. In this case, it's a final else statement where we say if nothing above is true, then just give print this. So key rules to remember is indentation matters. So you see the space here. If I highlight, there are one, two, three, four, five, five. I think four spaces. That's one tab. Um, that's important in if conditional statements like if, and else. Yeah, typically four spaces yes are given.
order matters. So Python checks conditions from top to bottom. So the first true condition triggers its block and skips the rest. So order matters is, let's say if something is true, the if let's say if I give the condition here as 91, then the the first condition is true. So it's only going to print the statement or the sentence in which is part of the first condition. That's it. It's going to skip rest all cases. So you have to remember that order, yeah, matters in Python. Else is optional. You can use if alone or with elif. Yeah. So else is really it's optional statement if you have to give final statement before you end the code, then you use else. If nothing is true, then at least print something. Next is another chapter in conditional statements. It's nested conditions. You can nest if statement inside your other if else block. So nested means one is inside the other statement. So both are clubbed together. So there's a master class, master condition and the parent and master conditions, or parent and child condition, you can say. It's somewhat similar to elif, but not exactly similar to elif. You are checking conditions. You're checking the secondary condition only if the primary condition is satisfied. Okay, so in this case, we have defined a variable num integer value. If num is greater than 0, which is true, again, it's 10, it's greater than 0, then you have to go inside and check something else. So first condition is true, which is good. Then you have to check the second condition because it's a nested if. If num is greater than 0, okay. If num is also less modulus 2, if num's modulus 2 gives 0, then print positive even number. So we are checking the even number here. So 10 modulus 2 obviously gives 0. So if you multiply 2 with 5, you get 10. That's why you don't get any remainder. You must now know that modulus gives you remainder, right? So remainder 0 means it's divisible by 2. Again, it's an even number, and because it's greater than 0, it's a positive even number. Okay. Let's say if this condition is not true, then and this condition is true, but the second condition is false. Then the overall output becomes false. Both the condition has to be true to get the final answer, right? Let's say if num is greater than 0, again, another number, let's take it 9. Um, is 9 modulus 2 gives 0? No, that's wrong. It gives 1, and that's why it's an odd number. So if numbers are not positive, then obviously it's going to be a positive odd number, and that's what's written here. If num is greater than 0, it's positive, but again, if it's not divisible by 2, then it's an odd number. If both these numbers are not there, let's say if number is not greater than 0, what does it mean? It means that there are no natural numbers here, right? There are no whole numbers. You have to use then the other numbers that user is giving, or let's say the number here is negative. It's not positive. That's why I use simple else statement and print the final that number is 0 or negative. Common use case. We are going to see common use cases. These are important ones. So user input validation. Where do we need this? We need this in types of forms, or also in password authentication for user login. So see the first line code. User underscore input. We have defined a variable, and we're taking an input. Enter yes or no. So user is going to put yes, either yes or no. If user input dot lower equals yes. So what happens is you have taken users input. There are many possibilities. The user gave you yes in all uppercase, lowercase, or in combination, right? Here, what we are doing is we are checking if user dot lower, when you convert, if you have given everything, we have to, you know what we are doing here? We are making any any uppercase or lowercase in a uh, eh, common format, which is lower. So let's say if user gives yes in all uppercase, we are going to lower it anyway. So everything, we are standardizing the user input here. So user input dot lower equals yes. So he gives yes, yes, it's true. Print you agreed. Okay. You agree to what? We don't know, but I'm assuming it's a form, or let's say it's something related to agreement of sort. Elif user input dot lower is no. If first condition is false, then it moves to the other statement, which is elif. Again, the user said no, then in that case, you disagreed. If both these conditions are false, then you give a final breaking command, which is denoted by else here, print invalid input.
Okay, so let's just give test this out. I'm going to use uppercase just to test. So it's going to standardize everything, all the response, right? So here you have yes, yes, everything is yes. Okay, game logic. Yeah, let's see another example. Player level is defined as 5. If player level is greater than 10, so player level is set at 5. And if player level is greater than 10, do something. Do what? Print unlocked advanced mode. The user is going to go to an advanced mode. Elif, if let's say player level is greater than 5, not greater than 10, but greater than 5, then print unlock intermediate mode. And if it's not greater than 5, in any case when it's not greater than 5, greater than 10, then the player level is less than 5. In all those cases, just put beginner mode. Okay, let's just run it. You are going to see beginner mode. Yeah, and the next example we have here is error handling. So file like this is a name of a variable, and we have defined it as false. So if file exists, um, which means file exists means it simply means it's true. Print reading files, but we have said it. Okay, if nothing is defined, okay, if nothing is defined, then you assume the computer system assumes that it's true. Here, it's not defined. It's file exists equal 1. Then by default, it's assumed that it's true. The file exists, print reading file, which is not going to be printed because it's false, else print file not found. Okay, a simple statement. Then next we have statement purposing example. So if the, again, it's a summary. Runs code if condition is true. Else if checks multiple conditions if the previous conditions was false. Else it's a final code if all the other codes do not give false answers. Then you use else to break the code. Okay. Now, this is where Python really shines, or any program language becomes difficult. Now we are going into the territory of advanced programming. And in advanced programming, things get really complicated. But if you know the basics and if you know the syntax, you can deduce where the code is taking you, or taking you in the journey, basically. Uh, we are going to start with while loop, but most important of these intermediate chapters is for loops. So you just have to practice for loops a lot to become really good in it. Let's see the first one, while loops. Loops are in general very important. There was code before that we had seen, right? We were going to come back to it when when we had covered the for loops. We are going to come back again and check that code piece. But loops in general is a way to get the answer until all the conditions are satisfied. Okay, we are going to run the loops until we get what we wanted. So a while loop in Python repeatedly executes a block of code as long as specified condition remains true. It is used when you don't know in advance how many times the loop should run. Okay, so we have a basic while loop. It's important to just check the answer. So we have while condition. While this is simple syntax, right? Nothing crazy is going on here. While condition, it's the indentation and the syntax formatting is same as if statement. If you remember, you have while, then you have name of the variable, and then you have a colon, and in the next line you start with indentation, right? So likewise, you are going to do it for while loop as well. So the loop checks the condition before each iteration. Okay, if the condition is false initially, the loop never runs. But if it's true, it's going to run again. You must update variables in the loop to avoid infinite execution. So if nothing is going is if nothing is satisfied, if the conditions are not satisfied, the loop is going to run forever until it gets the answer. But to avoid that, we have to update the variable, the initial variable, or it's called defining variable. In for loop example, if you remember, it was defined using I. Okay, so we have one example here, independence year quiz. So we have print when did America get its independence? Okay, this we are taking users input. We have defined a variable, taking int. Input can be anything, but we have to convert it to int. So we did. While here yr is not equal to 1776, then print you got it wrong. Enter you once again, and your int input. Okay, as I said, there are three steps. One is where you define the condition. You've taken user's input and you're storing it in var. Now, see, can be any number. any number present in var needs to have 1776. If this condition is not true, okay, if var is not true, then you are going to print once again. The user is going to print again. But there's one more thing. Var is now equal to int input. Okay. Mm. And then you get print. Um, finally, you get your answer. Let's run it. Okay. When did America get independence? I put 1772. You got it wrong. 1771. You got it wrong. 1776. I got it right. So what it is doing is it's running the loop. Um, let's do one thing. Let's just hashtag this code. So let's see what happens. If I put 1771, it breaks. It's actually running in forever loop, if you see. Yeah, look at that. It's still running. It's still going. I need to stop the code to actually break the loop. Yeah. So, okay. So what is happening here? You have var initially taken as input, right? Okay. You The user gave you a number, a year, but that year did not satisfy this condition. So you printed that you got it wrong, enter once again. But you see there's another line of code, which is here. What is happening is it is taking the input again to break the loop. So if you don't put this, then this is going to get printed again and again and again because because the initial input received from the user is it's only condition that it is taking. It's not doing. So this was outside the loop. So it is only going to run once, not again. So to ask a user again and again, you have to put the same statement inside the loop. So once the user puts the number the first time, it gets the answer that you got it wrong. Enter once again. But to enter once again, you have to add that input statement, right? And that's why you call this statement again inside the loop now. And that's why you are getting again and again and again until the user gets it right. Okay. So this is how it works. As the user to input here, the loop continues as long as the input is not 1776. When the user enters 1776, the loop stops, and you got it right. Right prints. Okay. This is probably the most important piece of code that was there in this code block. Okay. If you don't put anything here, this code will simply run infinitely. We have another example, which is an important one. The next example we have here is factorial calculation. Factorial is there's a formula for factorial. The original number and gets multiplied to all the how do I put it? Subsequent lower numbers, right? So I'll give you an example here. You're taking user's input in n variable, int input, enter their number. Then we have I equals 1, f equals 1. Um, okay. And what are these I and F? I and F are counters. So the calculation, it is used to, it's an increment counter. So 1, 2, 3, 4, 5. So this is how many times the code block is going to run. Exactly for this purpose, this is used. So it's predefined at position 1 initially, but then as we move ahead, this gets changed by a certain increment. Usually it's 1 plus 1. So we have taken input int, okay, I equals 1, f equals 1. Then while I is less than or equal to n, okay, while I is less than or equal to n, initially n can be anything which user puts in. While I is less than or equal to n, f equals f times I. So f becomes f, which is 1 times I. Initially it's 1 as well. And then the counter gets incremented by 1 position. So it becomes I equals I plus 1. Yeah, so calculate factorial. Um, we have in value as n, and the initial increment number is 1, and the factorial we are going to find out is f. But you have to see, if you see the formula of factorial, okay, so if you're finding a factorial 4, you multiply 4 times 3 times 2 times 1, right? So one step down, you are multiplying each number. So while I is less than n, okay, so factorial n is, let's say, 5. Let's take an example number. you know what? I'm not going to put this. I'm going to put number 5. Initially, the number is going to start from 1. 1 is less than or equal to 5. That's true. So f factorial is going to be factorial is going to be f. Initially, it was 1, but now it's going to be 1 times I. I here is 1. So that's 1. F factorial 1. Okay. So the first number is 1. And we are going to increment I because while loop is running from 1 to till the very last number, which is equal to 5. And then I is going to get incremented with 1, so I becomes 2. Now, these two numbers are you can ignore. These were just used for the very first time. That's it. In the first step, you know f is 1, and I has now become 2. So it's 2 less than 5, true, okay. But now we know f is 1, but I has changed to 2, so 1 times 2. So new f is 2. Then I, because it's 2, now it's getting incremented with 1 more, so it becomes 3. Is 3 less than or equal to 5 in this code? Yes. So the old f here was 2, but now it's getting multiplied by 2 times 3. So you see, it becomes now 6. Then I gets incremented again with 1, and it becomes 3. Sorry, 4. And then 4 times 3, then this loop continues, and you finally get a number f. In the very last item, which is 5 less than or equal to 5? This is true. So 5 also gets multiplied with the previous f number. But let's say finally you get 6. You increment 5 here, and I become 6. Is 6 greater than or equal to 5? No, right? Less than or equal to 5? No, right? So the loop breaks, and finally you get your factorial f, which was this number. And that's how you get factorial. So let's run it to find what's factorial. Factorial is 120. So this is exactly how it's explained here as well. Take a number, input, for example, you took 5. Initialize, so I, it becomes counter, f becomes accumulator for a factorial. So f is your factorial number, and this I becomes your counter with which the number is getting multiplied. So this loop runs until uh, I becomes less than or equal to n. If that's not the case, then the loop breaks, right? So multiply f by I, for example, f equals I times I equals 1, then f equals I times 2 equals 2, right? Okay. I hope this makes sense. So increments starts from 1 and ends at 6. Okay. When I is greater than n, the loop exists and the factorial prints out. So this is how the iteration looks like for number 3. So initially you have I as 1, f becomes 1 times 1 equals 1, then I becomes 2, f becomes 1 times 2 equals 2, then I becomes 3, again 2 times 3, and finally I becomes 4, but there is no condition for 4, right? We're only calculating till 3. So your final factorial here is 6, and that's it. You are done. And we have now a common use cases. So you have user input validation. So password, again, another example of while loop. So you have password given, while password is not equal to secret. Password equals input, enter password. Print access granted. Okay. So what is happening here is you have defined a blank string value, string variable, password. It is just a placeholder. While password is not equal to secret. So password password should not include secret word, right? It was blank, and you were hoping the user to put his or her password. But you have to make sure the password does not include this word secret. To do that, you are making sure that the password is not equal to while is not equal to secret. Password is you ask user to put the password. He puts again and again and again. Okay, here you're not here you are checking that the user puts the right password, which is secret. So you run the first loop, and you put the password. If it's not secret, it's run again, then run again until you get secret. And if password is not equal to secret, if password is equal to secret, then it prints access granted. You have given access to the user. So user's password was actually secret. So I put Johnny. I got an error. Then I put John. Okay, her error. This is not the password. I put secret. Okay, I got the access. Okay, you see here, you got the access because John has the password. Oh, sorry, the user has set the password as secret, and this is how you do input validation. Then you have menu systems. So you have a choice as a blank string placeholder. While choice is not equal to quit, print first play. Then you break the line, and the second line has setting, the third line has quit, and then you ask choice input enter choice. Okay. Okay. Here's the logic. So initial user had no choice. I mean, there was a blank placeholder. If the choice is not quit, it prints these values, and you have to enter the choice. And unless there's a quit, you quit the game. If if he's not quitting, then the loop hits again. Let me do it and show it to you. So you're printing play, setting, quit. You have to choose these options, and I choose play. It says no, you have to choose it again. Then I choose quit. No, you know why it's not taking quit? Because here I have to make sure everything is lowercase. To standardize it, you can actually put input and then put the lowercase, dot lowercase to actually, um, you can do this lower. Let me close this program. So you have quit, quit. And if I put quit here, well, it's still running. Oh, it's because I have to choose everything here. While choice is, what is happening here? While choice is not equal to quit, then run it again. Oh, because there's no breaking statement here. What if I do quit? It should work. No, my choice was quit. My choice was play. Okay. Maybe there is something wrong. There's an infinite loop. While choice is not equal to quit, then if I put quit, technically it should stop, but it's not stopping. You know what? And you chose, you quit the game. Let me run it again once more. Quit. Oh shit. There you go. Okay, okay, yeah, it's tough. So you see, if there was no breaking point, so that's why the code was running in infinite loop, type of infinite loop. So I put quit, it didn't know anything, so it printed again. So if I really wanted the program or the loop to quit, then I have to put the print statement outside while loop to make sure the program quits. Yeah, that's what I did. Then we have game loop, game loops. So game equals active. We have put defined Boolean type as true. While game active, so it's assuming game active is true. So game active is true. Player dot move. Okay, move might be a function. I am not sure what type of function is it. Does it give you the idea what type of function is it? Anyways, player dot move. If player dot health is less than or equal to 0, game active becomes false. Let's do it again. Oh, there's a code. There's an error in this code. Uh, I copied this code from somewhere else. Let's just factorial calculation in Python. Let's go up. Let's first see avoiding infinite loops. Yeah, so we have seen that we are getting various infinity, sorry, not infinity, but infinite loops. Um, when the print statement was absent in this example, you were getting the code, especially the print statement again and again. Okay, the code just kept running and running. To ensure that you don't have infinite loops, um, we have one example here. So the count starts from 0, count less than 5, then print stuck here. If we run this code, you will find something very interesting. Although the condition is satisfied, this keeps running and running. It doesn't stop because count is 0, but nothing is happening to that 0. So count is 0, 0 is less than 5, stuck here. But then the loop is not getting, it is not breaking at any point because there's no implementation of 0. So 0 is not becoming 1, 2, 3, 4, and so on. That's why it is stuck at this position of 0. So I have to force stop this execution. Let's stop this. To fix this problem, we have to do an update to the count. So count is 5, but we don't want it to get stuck at 0. We want it to count and move naturally as it is supposed to.
So we start with 0. Count is less than 5. Okay, that's good. 0 is less than 5. It is going to do the iteration, and the first iteration is 0. Okay, this is a critical update. We are adding and then adding 1 and storing that value in count. So the new count value is not 0 inside the loop. It's actually not 0, but 1. Does the value change? So it becomes 1, 1 is less than 5, it goes on, and if we get 4, 4 is less than 5, iteration is fourth. And if we put 5 is less than 5, now 5 is equal to 5. So this breaks and the code does not run any longer. Oh, I have to check one thing. And I have to check if this count value continues even outside the while loop. Or when I'm printing count outside this while loop, am I getting 0 or 5? Or maybe any count, the incremented count or the original count, which was 0. Let's just check. Print count. If I run it, yeah. You see, when the final count here was 5, and this count right here is, that's why Python is step after step programming language. So the initial count does not matter anymore once we enter the while loop. So the while goes on, and count gets incremented. And finally, when you print it, the final count was 5, not 0, even outside the while loop. So we have seen how to prevent infinite loop in while loop. The next is break and continue. Break is a forceful command to exit the code. Okay, so while true, okay, answer is input. Enter quit to exist, exit, not exist. If a and s equals quit, break. Break means get out of this code command. Mhm. Let's test this out. So enter quit to exist. I'm not going to quit, so I do yes. So it's saying no, please continue. Please quit. I am not going to quit, so I say no. Okay, still an error. Okay, so what is happening here? When I'm putting yes, it's true. Okay, I get yes, but this is not equal to quit. Quit. The answer yes is not equal to quit. So it's not breaking. It's going again to the input. What is input? Enter quit to quit. No, I'm not quitting. Okay. What if I put quit? Just check what happens to the quit code. It breaks. You know what happens? If a and s equals quit, break. Break gives the result false. And that's why while true is not the case anymore, it becomes false. So while loop is not running. Okay. Continue is to skip the next iteration. Let's say we have met a condition, but we don't want to stop the loop. But we also want to make sure the concurrent uh, the concurrent step is not considered. Instead, we want to skip that iteration. In those cases, we use continue. Let's take this example to explain better. So we have a defined number value as 0. So while num is less than 5, okay, num plus equals 1, okay. So while num equals 0, which is true, 0, it's less than 5, so it is going to enter into the loop. Now, initially the num was 0, so we are going to count it 1, okay? If 1 equals 3, we are going to count, okay, just remember this, we are going to count, and the new num value is not 0, but 1. So we are comparing 1 equals 3. No, that's not exactly the case. Continue. So it skips printing 3. It does not print, continue means it's not going to print the number, which is 3 here, okay? So if num equals 3, and we know the num is 1, not 3, it's going to continue. Continue means going to get back to counting or get back to the initial step of the loop. So what's the next step? Now, num was 1, it becomes 2. 2 is, again, not equal to 3. Continue, it's not going to print anything. It's going to skip this step. It's not going to do this. It will continue and commit to the next step, which is num plus 1 plus 1. So num now is 2, so plus 1 makes it 3. Okay, now it's 3. 3 equals 3. It's not going to do continue. Instead, it has gotten the response, the correct response, so it will print the num. The new num is now 3. Okay, so it printed num 1, 2, but it skipped num 3. So it isn't printing because num equals 3. It is going to continue not do anything and just continue to the original step. Otherwise, it was going to print num 1 1. It's not num. Let's say 1 is not equal to 3. Continue. This was outside if loop, so it is going to print num. Okay, yeah. How about if I put this inside the if loop? Okay, yeah. There's an error. It has to be outside. Yeah, 1, 2, 3. 3 is skipped, 4, and 5. So in summary, we have seen while loops run indefinitely until the condition is met. Update variables inside the loop to prevent infinite execution. Use break to exit early or continue to skip the iterations. So this was the summary. This is the syntax that you are going to use. Now we are coming back to our factorial calculation that we did before to better understand while loop and factorial in general, because this is one such mathematical operation which will come again and again in data science. So yeah, not just factorial, but factorial is very common to statistics, right? And that's why the problems like these will generally pop up again and again. So we have factorial calculation in Python. So understanding factorial. So the factorial of a non-negative integer n is denoted by n factorial. It is the product of all positive integers from 1 to n. So example, 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, so it becomes 120. In some special case, we have 0 factorial. 0 factorial is 1. Okay, so we have one problem statement. Let's check out the problem statement. The question asks us to write a Python program that takes an integer input n, computes its factorial if n is non-negative, and handles edge cases, for example, n equals 0 uh, or negative numbers. So negative numbers don't have factorials, and 0 factorial, if n equals 0, which means 0 factorial will give 1. It's by default. So we have to make sure we are taking input as integer. We are computing factorials n for non-negative numbers only, and for 0, we are handling that special case where n equals 0 gives 1. So we have test cases here. 5 factorial will give 120, 2 will give 2, 0 will give, by default, 1, minus 7 will give invalid input. Okay, let's see the code before we run it. The first condition was to take integer input. So we can take any input, but we have to make sure the input gets converted to int. We are using int function to convert it. Now, if you remember, we have two variables here. One is to count and another is to accumulate. When we do more and more problems, such problems like these, we will understand why we will get very good at defining our own variables. But so far, just remember that factorial calculations have two distinct variables, for one for counting and another is for accumulation. So if n is greater than or equal to 0, which is true, again, if n is not equal to or greater than 0, then there's no need to put those factorials are not possible, like minus 7, right? So if n was minus 7, this will just take you back to the else statement and you will leave the loop. You will not even enter the loop. But let's say if it is positive, while I is less than equal to n, okay, so in this case, n can be anything, 5. So you have accumulator equals, the initial accumulator number is 1. 1 times 1 gives 1. And then I gets incremented by 1. So the next I value is going to be 2. This will go ahead and change 2 to 2 times 1 to 2, then 2 times 3, that becomes 6, and so on. Finally, you will print factorial is f, and you will get the value as, you will get your factorial value. So let me run and take any factorial, 6. So you get 6 as 720, right? So this is very straightforward. This we have seen before as well, so nothing new here. But let's go ahead and see what is happening in this code, and then we will take care of the 0 code as well. Input handling. So n equals int input, enter the number. Okay. Um, so we are taking the input, but we are also handling it, which means converting any type of input into string. So we're taking the integer value. Edge case check. We have to check if we are not taking any negative numbers. So in those cases, we put n is negative, prints in invalid input. Then we have factorial calculation. So we initialize I equals 1. Okay. We initialize I is 1, which is counter, and f is the accumulator, which is again 1. We run the while loop and do our calculation. For in this, they have taken n equals 5 as an example. We do all the calculations for each iterations, 1, 2, 3, 4, 5, and at the fifth one, we get the answer 120. I is now 6, and we have to leave the loop because it's not less than or equal to 5. So we left the loop and we went outside. While loop executes while I is true, update f. Okay, we have edge cases. N equals 0. By definition, 0 factorial equals 1. The loop does not run I equals 1 greater than n equals 1. So f1 is printed. So, okay, by default, we don't have to put any other condition. It's taking 0 as 0 factorial is 1. So if I put 0, what do I get? 1. You know why we are getting 1? It's a very smart way. They're solving this problem. So when we did 0, 0 is less than or equal to 5, which is true. So f is now 1. Okay? I'm sorry, I is 1, not 0. So we took the number 0 is 1 less than or equal to 0, because now I have put 0 as my n, which cannot be the case. So it's not going to run any of this. This is by far not going to run in at all. Okay, so we leave this loop, but not this print statement because it's outside the while loop, but it's inside the if statement. So print factorial is f. The accumulator, the initial value of accumulator is one, so it's going to print one. It's pretty neat if you ask me. Variable initialization. I think you should remember this code and understand the logic behind using this code, especially why I is the counter and why f is accumulator. Okay, so these were the key principles that we had. And if we go ahead and solve another one, find the number of digits in a number. In the problem understanding. The task is to write a Python program that counts the number of digits in a given integer, including handling edge cases like zero and negative numbers. Okay. So we have a test case 1, 2, 3, 4. Expected output is 4. Why is that? The test right program that counts the number of digits. Oh, okay. So we are counting each number of places that this input is taking. Okay, that's very neat. And by the way, you can't use length function because this is not a string, right? That's why. Okay. So the first piece of code here is let's start here. Input, because that's what we understand. We're taking an input, but we are also making sure that it's an integer. So we have counted and converted it to integer. We know it's integer. And then we are running absolute value. We want to make sure, even if it's negative, we are getting absolute value. Okay, so let's say if this was minus one, minus two, minus three, minus four. Technically, if this was string, there were additional four minuses, which will get counted if you were to use length function. But here we're not using length function, we are using absolute to make sure even the negative becomes positive. Okay, then we have a counter. The counter here is 1 digits, while n is greater than 9. N is greater than 9. Is it going to be the case n is greater than 9? Yeah, okay. If n is greater than 9, then n equals n floor division 10. So floor division gives you the closest number, okay, to your to your original number. Yeah, so if the numbers n is greater than 9, then it does the floor division of by 10. So uh, the floor division gives you the value of the divisor, as I have said before. So if, for example, 10 will give you the third three places. If the number has 4 digits, it's going to give you 3 digits. Okay, and then to get the next digit, it will give you one less. It's a tenth place, right? So to get the units place, you add one, and this will give you the number of digits in a given input number. But this only works for where n is greater than 9, which means n 10 and so on. For less than 9, it will take default value, which is 1. Because from 0 to 9, all the values have only one units place, right? Not 10th or 100th place. This is exactly how this code works, and this is explained in this in this explainer. And is taking absolute value, converts input into each integer, and ensures it's a non-negative by using absolute value. Then edge case handling, you're doing edge case. So you have input handling, you have edge case handling. These two are very common in while loops and these type of questions, especially in while loops in general. So we have handled the input. Now we are handling the edge case. Edge case is a unique case when n is a single digit number, including 0. The loop does not run, and it takes the default value of 1. Then we have digit counting. So continues dividing n by 10, integer division, until n becomes single digit number. So you take n so you take n as, for example, I put a large number. Okay, I take 1024. You see, I am getting four values, right? 4 digits. How it's doing it? So it's taking the first division. I put the number. Is this greater than 9? Yeah, it is greater. It is getting 1024 is getting the floor divided by 10. I did that. So what am I getting here? I'm getting 102. 102. 4 gets off because I'm dividing the unit place. Then I'm going to get 102, and the digit counter gets incremented by one more, so it becomes 2 now. Then I'm going to do the floor division again because it's greater than 9, so it will take one more position. Now the 10th position, because it's getting divided by 10, right? Now how many, so what's the next increment? 3, right? 2 plus 1 gives 3. I'm going to do one more time because it's greater than 9, it's 10. So if I do it again, I get 1. The number doesn't matter. The number actually, so 10 4 divided 10 gives 1. So 1, 1 is not greater than 9. It leaves the loop. So what was the final digit that I got? It's 4. So this is how this program, this code um, is running. So it is counting as it's dividing. So it's eliminating all the units place, then tenths place, then hundredth place, thousandth place, and so on. It's eliminating values from the unit places from right to left. Key concept here is to remember is absolute. This is the first time we were using absolute integer division. Again, integer division, what it does is it removes the last digit of n in each iteration, and that's why it's used in programming language. Then we have loop termination stops when n is a single digit number. N is less than or equal to 9. That's why. So we have loop termination here. So stops when n is a single digit number. That's pretty straightforward. And then we have an edge case where we were handling the absolute value to make sure not non-negative or non-negative numbers are only considered, not the negative one. I hope this makes sense. Let's now go ahead and do reverse the given number. It's a new question. Again, it will use while loop, but this time we are going to learn new concept here. First, we're taking the input. We are making sure that input becomes integer, and also taking the value in absolute terms, so non-negative number, right? So here we are not using any counter. We are using sorry, we are using a counter, which is actually we are not using a counter. We are using an accumulator. Ideally, while loops generally have accumulator. It's only the case of factorial where we use accumulator as well as counter. So typically, you will find counter in only for loops. So why for loops and other as well, but for loop is very famous where counter is used. Uh, Reverse num equals 0, so that's basic. While n equal is greater than 0, num equals reverse num times 10 plus n modulus 10. Okay, this is the logic that is getting built, and we are going to see. To solve these types of problems, you have to build the logic, and ideally you should do that on a piece of paper, and then type that code. So before you go ahead and actually type in Python, probably you should write a pseudocode. So writing in English language, writing in your language in simple terms, how you're going to solve that problem. But anyways, you're going to see how this problem gets solved. Let's just take one example, 1024. Okay, that becomes 4201. Okay, now we are going to see how this problem was done. N is defined 1024. Okay, now n is greater than 0. This is true, and it's greater than 0. Reverse sum is times by 10. Okay, I did that. That becomes 10240 plus the n number is getting divided by 10. So if I do, how much would it be? 1024 modulus 10. So if you divide this number by 10, you will get 1020. So what's the modulus? What's the remainder? Remainder is 4. So you got 4 here, okay? And then you do floor division. So let's see here. N modulus 10 extracts the last digit. So when you do modulus, it gives the last digit. When you do floor division, it eliminates the last digit. This is something you have to remember. So modulus, what it does is it extracts the last digit. So 1, 2, 3, 4 modulus 10 will give you 4. Okay, 4. Got it. And then reverse sum times 10 plus and so on builds the reverse sum. For example, 0 times 10, okay, 0 times 10 plus 4 is 4. 4, why is it 0? Oh, because reverse sum is 0. Okay, okay, understood. Understood. You know what? Let's take this example so it becomes easier. 1, 2, 3, 4. Yep. 1, 2, 3, 4. Now becomes 4, 3, 2, 1. So how did it become 4, 3, 2, 1? So 1, 2, 3, 4 it gets divided by 10, so you get 4. So this part becomes 4. Okay. Now what about this part? Initially, reverse num was defined as 0. So 0 times 10 will give 0. So the reversed number that you got here is 4. Okay? Just remember that. You got 4. So your first output is going to be 4. But you have to do the counting again because the everything is not over. So how do you remove, because you have accounted for this last digit, but you have to remove this last digit to take care of the other digits, right? So how do you do it? You do a floor division. Floor division by 10 removes the last one. So what's your output? What's the new n? N is 1, 2, 3. 1, 2, 3 is greater than 0, but now n is reversed. Num is still 0. Just remember that. It's still, no, it's not 0. Okay, just remember that. It's 4 now. It's 4 from the last operation. So let's take the simple part, which is 1, 2, 3. 1, 2, 3 modulus 10. What does it give? It gives the very last number, which is 3, right? So you got 3, and 3. And what about this one?
and this becomes 4 times 10, which is 40. But this value gives 3, so the new number is now 43. Reverse number will give you 43. You eliminate again. Again, this becomes your 43 times 10 will give you 430. But because you have taken this value, this will give you a remainder of 2, then it becomes 432, and this goes on, and finally you get the answer 4321. I know it's complicated, but probably if you understand the logic, this becomes easier. I hope you will solve it. In fact, you know what? I will make future videos where I will type these questions myself and explain, do more complex problems surrounding these questions. That will give you a better understanding of how to solve this question in particular. So this is how it works. Then reversing digits in numbers. Reversing digits in a number. So you have a problem in hand. The task is to write a Python program that reverses the digits of a given integer, including handling negative numbers and preserving the sign. Okay, so we have rearranged the number before. The only unique thing that we might have to do in this problem is to also handle negative numbers and make sure the negative numbers are not getting displaced. So we have some input cases where input has been received and expected output is there. Okay. So in the end, we are taking an input, enter the number, and that number gets converted into integer, because that's exactly what we want. Then num equals absolute n. Okay. So we're taking an input from the user and storing it, storing the value in n, and then we are taking the absolute value of n. Okay. Um, and then we have one counter, and the counter is reverse num, sorry, and that has been set to 0. Let's start from 0. Okay, and then when is greater than 0, okay, in this case, if number is greater than 0, digit equals modulus number of 10, num modulus 10. Okay, so we are extracting the last digit, okay, and reverse number times 10 plus digit. So it builds reversed number. Num equals num floor division 10, the most last digit. Okay. Hmm. So as I'm seeing here, reverse num is actually the counter, not is the accumulator. So we are taking the absolute value of what the user has provided, okay? And then we are checking for all the positive numbers. So while num is greater than 0, which means the positive integers, hmm well, in those cases, num is going to be positive, isn't it? Yeah. The num is actually the absolute value of n, which I think will always be positive. Um, okay, we will see. So we first take the num values of positive numbers. So there is a digit. And where is digit stored? Let me run this code. I think there's something wrong with this code. It turns out it's working. So if I take 4, 3, 2, 1, it becomes 1, 2, 3, 4, isn't it? Yeah. Okay. Anyways, so we have defined uh we have defined a new variable inside while loop. Mhm. And num is the absolute value of the user. We're taking the modulus. So modulus of 10 means it extracts the last digit. So that's pretty straightforward. We have seen this before, right? Now, the next line of code is reverse num, which was this counter, equals reverse num times 10. So it starts with 0, so it becomes 0, plus digit. So whatever the remainder was after taking the modulus. So the remainder gives you the last digit. So last digit gets stored in digit and displayed here. And when you times that by 10, that gives you the units place. Hmm. Okay. Mm, yeah. So now you have just taken the last digit and put that in the units place. And then num equals num num floor division 10. So num, okay, this one. And you, okay, so this is the counter. This is the counter, this is the accumulator, turns out. Turns out once you have num was 0, num can't be anything, right? So let's say 4, 3, 2, 1. I will take this example. Is 4, 3, 2, 1 greater than 0? Yes, it is. Now we have to remove 1 from this code. So what we do, we define a new variable, store the value of its remainder. So when it's divided by 10, this gives you the very last number, which is 1, as the remainder. That remainder is stored in digit. Next up, we have reverse num, and we are going to multiply reverse num, which is 0, times 10, which will n plus the digit. This takes it, when you multiply it, this gives you the first number. it reverses the number. So now the last number, which was 1, comes to the very first place. Okay, that makes sense. Now, again, num is 4321, but we are doing floor division. What floor division does is it completely removes this part and only considers the new num becomes 432. 1 is lost. Okay. And when you do the modulus, it gives you the last number. When you do floor division, it removes the last number. That's the only logic. Now, if n is less than 0, okay. Oh, okay. I was getting confused with num, but instead we are taking n as the possibility where user input is less than 0, which means negative integer. So in those cases, reversed num. So this loop is complete. Okay, loop is complete means even if I put negative here, it goes 1, 2. Let's take the another number. Okay, the new num. Okay, let's take this example and finish it before we come to this code block. So 4321, the last digit gets removed. Okay, and we have a new num. New num is 432. Now, is new num greater than 0? It's true, it's greater. And when we do 432 modulus 10, that gives you 432 modulus 10 gives you, it extracts the last digit, which means you get 2. So reverse number, now reverse number is 0 again, isn't it? No, reverse number is actually the last number, which was 1. So 1 times 10 plus digit. So the new number becomes 1 times 10 is 11 plus 2 gives you 12. So the new number becomes 12. Okay, this makes more sense. Now you do num for 432, okay, and you do the floor division by 10. It removes 2 from uh, this number, and the new num becomes 43, only 2 digits, still greater than 0. It do the same thing. You get the remainder as 3. It gets stored in digit 3, and then we have uh, the old one, which was what? Which was reverse num was stored as what? 12, if you remember, 12, right? 12 times 10 becomes 120, and then the new digit, the digit before was 3, it gets stored, so it becomes 123. Likewise, you do, and you complete the loop, and you get the number 1234 reversed of the original number, which was 4321. And but that's not enough. Once you finish the loop, you get the new number. You have to check if the sign is correct as well or not. So if n is less than 0, which means it's a negative integer, then the reverse num should be minus. Okay. So whatever the final reverse num was what? 4, right? Isn't it? So 4 and 123 times 10 plus 4. Okay, so your new reverse number becomes 1234, but then you have to change the sign because we have to restore the original sign, and then you can print your number and give reverse num as the final answer. I hope this makes somewhat sense. You will have to try this question on your own to see if you are making any mistake. Otherwise, don't worry, we will do plenty questions in future as well. So this will give more ideas and build our logic. So how are we doing it? How is this program working? We are storing the num in the original number, which can be positive, negative, or 0. So n is stored here, integer. Then we have absolute value. We are taking absolute value. The reason why is because we have to simplify reversal, and this you have to restore these signs as well, right? That's why we're taking the absolute value here. The first step is once the input handling is done, making sure the number, the user input is converted to integer, and then we are taking the absolute value as well. Once that input handling part is taken care of, then we move ahead with digit reversal. What happens here is we are taking the num value and taking the modulus, extract the last digit. I think this is something you have to remember and probably memorize. What's the use of modulus and what's the use of floor division? Okay, so we have num equals 10, num modulus 10, which extracts the last digit. Then you put that in an accumulator times 10 plus digit will give you the new values or the reversed list, right? And then we have num floor division 10 that gives you it removes the last digit again. This gives you the remainder, which ideally is the last number, and this completely removes the last number. Reason why is because we have to eliminate numbers to move forward. Okay, sign handling, it was simple. If you get negative, then you use if statement, conditional statement to reverse and restore the original value, original sign. I'm sorry. Okay. Yeah. So there are some edge cases which are exceptions, or n equals 0. Um, loop does not run. Output is 0. Okay, single digit number. If you put anything in single digit, it's going to reverse. Nothing is going to be practically reversed. It's going to return the same thing. Yeah, so these are step-by-step execution. So first iteration, we have 1, 2, 3, 4. We take the 4. Initially, this was 0. It was defined as 0. If you remember, reverse sum here, reverse num was defined as 0 here. So that's why 0 times 10 plus 4 equals 4. Then the floor division gives you 1, 2, 3. The floor division, the new num becomes 1, 2, 3. You do the extraction using modulus, you get 3. And then 4 times 10 plus 3, 43. Okay, and then you have 12. Yeah, this thing continues, and your final output is 1, 2, 3, 4. I hope this makes sense. The only thing which could be counted as key concepts here is modulus operator, which is percentage modulus to get the remainder, which is the last digit, and floor division or integer division. Floor division will give you will remove the last digit. So that's the only thing. Sign preservation, absolute function. You have used this before, so there's no worry. Next up we have here is palindrome check. So we have seen example to build our logic using reversed numbers. We solved that problem. The next problem to build our concepts is palindrome check. So palindrome, it's pretty straightforward, right? The it's basically a number is a palindrome if it reads the same backwards. 1 to 1, 1 is 1 to 1, right? Nothing new in this. So and there, not just numbers, even names can be palindrome. I don't remember any case. If you, what could be a name which is a palindrome? I'm not getting anything on top of my head, but anyways, we have one example, 1 to 1. So we are taking user input and storing it as int value. So there's one counter which is reversed num. Uh, there's so much here. So what we are doing is we are converting. You're taking absolute value, okay? We are taking absolute value n, okay, positive number. We are converting it to string, okay? There is a new method, or you can say an alternative method of solving or reversing a number. And this could also be displayed well, this could also be used in reversing the numbers or finding out if a number is a palindrome or not. So one such example, or this is a very short code, if you see. Although we have used while loop to reverse a number, that was one method, but there's another method to reverse a number which is much faster in coding. But still, I think you should remember both the methods. In fact, you should learn this to to make yourself more comfortable with while loop before you move ahead and use shorthand methods to ease your work, right? So we are learning the concepts, not making our workflow efficient. So that's the goal. But anyways, here's one example. So we are doing is checking the palindrome as we have discussed before. Palindrome is the number reverses, the backwards and forward both are same. So here we are taking an example of 1 to 1. You can use any number as I am taking user input and storing that value in it. Here's what happened. So we are reversing the number. Reversing the number is stored in reverse num. And just see the first bracket. Whenever you see multiple brackets, or whenever you see the code is going offhand and you cannot understand a thing, just go and look at the very inside of the code. So here we have absolute value of n. N is defined as 1, 2, 3. Um, let's take an example, 1, 2, 3, right? This is non-negative number, it's a positive number, so it becomes 1, 2, 3 absolute value. And then we are taking the string, we are converting it to a string. The reason why, because string, changing the places in string is much easier than in integer, because in integer you have to run while loop to, if you remember, remove the last place, then the first digit, second digit, and then run the counter, run the accumulator. You don't have to do yours. So what you do here is you simply take the value and convert that to a string. And in string, the slicing becomes very easy. If this concept you have studied before, if you remember. So in slicing, this slicing always happens in a string, right? So in a string, we want to choose a number. So we have converted the number in string, and now what we are doing is saying the computer to start. This is a start. This is the end, and how many increments are we taking, or how many steps we are taking. So the number starts from the very beginning till the end because there is no value here, and you're saying the computer to take the step backwards. It's minus. So what it will do is take this number and print it first, then it will take this number and print it second, then this number. So it's simply what it is doing is reversing everything. And the reversing is giving you a string value, but then you have to convert it to something, and you have converted it to int. And that's it. This piece of code gives you a reverse number. But because we are also checking palindrome, what we are doing is using a shorthand method of if statement. So if
multiply this number with -1 if it's less than 0, or if it's not less than 0, multiply it by 1. This is a very efficient code written here. This is another way, or if you want, you can store it in another variable and then use that as a multiplier and run the if statement as you would do here, with proper indentation and all those things. But in one line, you can use this as your code. Okay, so you have this code, you have reversed one, and this is also going to give you the sign. This part is going to give you the sign. This part is going to give you the reverse num. And finally, what I did here is printed the reverse num just to show you if the number is reversed or not. And here we are checking, is it palindrome? Now the original number is equal to reverse number. This will give you a Boolean output, either true or false, right? So let's test it. 1221. 1221. Let's check if this is a palindrome. Yeah, it is a palindrome. So it reversed and checked that the n equals reversed. Both the numbers are the same. That's why it's printing the true value. Now, just to check if the numbers were actually reversed or not, I'm printing the reverse num as well, right? So to test that, I'm going to put a different number, 1234. This shouldn't be the palindrome. This shouldn't be a palindrome. But you see, the same code that you wrote here gave you the value 1234, the reverse is 4321, but a single line of code gave you the reverse value here, which is 1234 converted to 4321. So I hope this makes sense. Nothing new here. Earlier, you used to use the percentage sign to determine the last value, extract the last digit, place it at the front, and you were removing the last digit as well to make sure the counting doesn't stop and you progress or move forward. That was one way. The other way was to use this. Both the ways work, but I think you should first learn the while loop. Well, we are again in the same problem, finding palindromic numbers. But this time, instead of using the shorthand code that we used before to check and palindrome, and before that reversing it, using the one-liner code that you saw before, we are now using while loop. In the same traditions that we used while loop before. We are going to use it again. This will make code much more complex, but will also give you better understanding of how the logic is built. So here's a problem statement. Determine if a given number reads the same backward as forward. So for example, 121 or 1221, including handling negative numbers -1221 is considered palindrome because the sign is ignored. Okay. So finding a palindrome. Let's look at the very first code. This is taking integer value from the user and storing it in n. Okay. Then we are making it an absolute value because the sign does not matter. Sign actually will be used later on. Till here, I think this is following the same pattern. Next up, we have reverse num equals 0. Again, same pattern. Three lines of these codes you have seen before as well. Next up, we have original equals num. So this is a new variable which we have defined, and this is stored as num. And num itself is going to change. What we are doing here is save the original absolute value. Okay, this will come in handy when we are comparing the reversed num to the original num, right? We could have used num as well, but if you remember inside the loop, num is going to get changed multiple times. So this will give you a false result. Instead, we are using original to make sure even if the num is getting changed, the original value is still stored in original variable. Then coming next, we have while num is greater than 0. Okay, num is greater than 0, digit equals num modulus 10. What we are doing here is we are removing. Okay, we are removing the extracting the sorry not removing but extracting the last digit of the user given number, storing it in digit. Again, reverse sum in the unit place. We are doing 0 times 10 plus digit. This is getting stored in reverse. So here, this I think I'm 100% sure this piece of code you already have seen before, where we are taking the number from the user and reversing it. What has changed here is once the number is reversed, we are comparing it if it is reversed, and if the reverse number is equal to the original number that the user gave, uh, removing the sign, regardless of the sign, then it becomes a palindrome. Else, it's not a palindrome. So we have this line of code, which is which gives exact same output as this line of code. It's only to learn and probably brush up your concepts that we are using while loop. Okay, it's better to use while loop in this case. Let's run it to see uh, what kind of output we get.
Okay, I think it's connecting. But anyways, so you have input handling and is storing the input from the user. You have num absolute value. So the first thing you're doing is input handling, then digit reversal. You have seen this digit reversal before, which is this while loop. Okay, then you're doing the palindrome check using if statement. Again, that's pretty straightforward. And you are handling some edge cases. So let's try one such example, 1, 2, 1. So let's run it. Oh, it's a palindrome. To test the number, let's also print the reverse number as well, just to make sure you are seeing what the reverse number is. So 1, 2, 1. What's the reverse number? It's 1, 2, 1. Let's take a new reverse number. 1, 2, 3, 4, 5. Okay, let's run it, and then we are going to see not a palindrome, and here's the reverse number. So I think by now you should be well aware of how to reverse a number, how to check if the number is palindrome or not. Okay, next up we have for loops. Like for loops, so the only difference, the main difference I would say in when you are seeing while loop and for loop, while loop has no starting point, no end point unless you define it. So there's no range. But in for loop there's a range. It has a definite starting and a definite end. While loop can run if there is no breaking point, if the condition is not satisfied, it can go on for a very long time. But in for loop, you define the end state. So we are going to learn it better by solving the problem statement. So problem statement here is calculate the sum of first n natural numbers using a for loop. For example, for n equals 5, sum equals 1, 2, 3, 4 plus 5, 4, 5 equals 15. So what we are doing here is we are doing the sum of first natural numbers, n natural numbers. Very straightforward. Here we are taking the user input and storing that value in n. Again, this is similar to what we have done before. And we are taking sum equals 0. This is a accumulator. So what accumulator does is it stores the value, the final value. Okay. So let's run it. When I run it, then you will see the code and how it progresses. So you have 1, 2, 5, 1, 2, 1 plus 2 plus 3 plus 4 plus 5 gives 15. Let's see how it works. So user has defined the value 5 here and stored in n. Sum is 0. Okay. For I in range 1 plus 1 comma n plus 1. Okay. So I in range. What does range mean? Range is any specific, or you like we have slice in string. You have seen slice before, right? So let's say there is a name, for example, loop. So the word loop has placeholders starting from 0, 1, 2, 3, right? So we were using, let's say we have to print double O or let's say OP. Then we were using slice function to to pick and select the numbers using start and end position and the steps, the counting, the increments. Likewise, range is also a function where you're taking the arguments. So we have an argument, you have a start and stop and step as well. This is defined here in range. Step, if not given, is by default 1. So the number is going to start from 1 till n plus 1, which means if I have given 5, it will go till 5 plus 1, 6. So what is I here? I is another is like is a variable where it is counting the digits inside this range. Okay, so this whole statement is your condition. Once this condition is there, inside the for loop you have sum plus equal 1. So whatever the sum is 0, it gets added to I number. And finally, there's a print statement. So let's take 5 an example. So you have defined 5. I will start from so I here starts from 1. Okay, so I starts from 1 here. Why does I start from 1 and not 0? The reason because in this the range starts from 1 and goes till 6. So first number will be I. So I sum will become 1. So the first increment will give you sum equals 1. But this condition is not fulfilled. That's why for loop is still running. The second number is still in the range. Yes, second is there in range. So here it becomes 2. I becomes 2. So this gets added to 1 plus 2, which becomes 3. So sum is now 3. Then the next number is third. So 3 is in the range. So the new number, the sum is going to be 3 plus 3. So it becomes 6. So this goes on and on until we reach 6.
So until we reach 6. So it's not taking sixth value, it's starting from 0. I was wrong. I'm sorry. It starts from 0, not 1. So it starts from 0 and goes to 5 and ignores the 6 because 6 is not considered. So it only goes till 5 because 5 v1 till 5. So 5 plus 1, 6. 6 is ignored. It goes till 5 and you get the answer, which is 15. Again, you have how the code works. Input handling is very straightforward. The number is getting stored in n. Loop execution, you have range. Range is defined, generates number between 1 to n. N is inclusive, n plus 1 is not. There's an incrementation which is going on. So I'll put 15. You get uh, you get the output as 15. Here's the important thing. Range has parameters. So start by default is 0. So when you do range 5, you start from 0, 1, 2, 3, 4. But here we started the upper bound as 1. So 1 to 5 will give you 1, 2, 3, 4. That's why for 5, there are only 4 numbers here. So for 5, you had to do 5 plus 1, which is 6, right? That's why you had to do n plus 1. Default is 1, but let's say if you want to skip like you did for slicing, you do one increment of 2, then 1, 3, 5, 7, 9. It does the increment of 2. So this was basic while and for loop. Next, we are going to see printing and how to format the printing in Python. Previously, we have seen print statement formatting uh, in various ways. For example, changing new line or removing a separator. Likewise, there are other parameters that you can put inside print statement to do further changes. Okay, we are going to see them one by one. So one is end parameter. So if I remove this end parameter, let's see what happens. So if I remove this one, okay, it's a simple for loop. It starts from x in the range 3. So because the start point is not given, so range is going to start from 0. So 0, 1, 2, 3 is not going to be there. It will be excluded. Print x. So when I'm going to print, I'm going to get 1, 2, 0, 1, 2, but in different lines. There are separate lines, right? Well, let's say if I just go ahead and print, then you have 0, 1, 2. Okay. So now the output is printed in the same line. This is where end function end parameter is given inside print statement. Next is sequence parameter. Oh, sorry, not sequence, a separator. So it defines a separator between multiple lines. So, for example, you have given 3 inputs, date, month, and year. The output is going. If I'm going to remove this, you will see that the output will also have uh, these numbers, but without putting anything inside, without any separator in between. To add that, you use separator and you define what kind of separator you want. So I'm going to put, let's say, I'm going to put comma as well. Okay. If I run the code again, there will be comma. Well, this does not make sense for date, so I'm going to put the hyphen, the dash back. So 10 May 2022. Okay. Moving ahead, we have string formatting methods. So you have one which is f-string. We have seen f-string before, right? But f-string is coming again. So you have 4 in range, 1 and 4 prints. You print f statement, f, then the quotation marks. To put a variable, you define the curly braces, and inside the curly braces, you put the variable name. And here we are doing cross to indicate there's a multiplication which is going on, and then another curly braces for the second number. And finally, you are going to multiply. When you run this code, you get all the values in this range. Instead of printing this again and again for all the possible outcomes, you are going to use this to print one after the other. Okay. So the first time num will be what, 5, and I is 1, so 1, and then 5 times I will give 5, then 2, then 3, then 4, and so on. I starts from 1, 2, 3, and does not go till 4. Mhm. Okay. Then we have string formatting. So it uses curly braces placeholder with indices or names. So you have print curly braces times 1 equals 2 dot format. Okay, dot format, what it does is places these numbers here inside and gives you the result. Mhm. Yeah. So it's same as f string, just a different way of putting it. So curly braces 0, 1, 2 is defining the placeholder. So 0th position, 1st position, 2nd position. If you had something else, let's say if I'm going to do, let's put one more number. I put 50. But this is what 0, 1, 2, 3, third position. If I put a 3 here, this is not going to print 10 anymore. It's going to print 50. Look, right. So I think you get it. Then you have old style modular formatting. It is borrowed from C, uses percentage D for int and percentage F for float, etc. So when you place these numbers, so you are going to uh, put all the integer values inside this. Then you use modulus. You define what are you going to put. So 5 times 3 will give 15. Likewise, if you wanted to put float, these numbers should have been float. And then if you would put F here, this will give out all the float values. Okay, I hope that makes sense as well. Then we have precision control, floating point formatting. Okay, this is important because when we are dealing with statistics, it, it will be really important. Uh, if you are using floating point formatting, this will be very, very important. The reason being, the limit decimal place with these numbers where n equals a number of digits. So pi equals 22 over 7. I think this is clear. Then you have print function f pi equals pi dot 2f. Floating point formatting. Okay. In statistics and mathematics, where you will have probability values which will be in many digits after a decimal point. In those cases, it will be important for you to put number of digits. Okay, so for example, value of pi is continuous, right? That's why you only take two decimal places. So to do that, you are using f string again, pi, and then inside the curly braces, you are going to define pi value from here, but you are only going to give two decimal places. So it is taking pi values till two decimal places, and this is the syntax for it. Another way to write this is pi two decimal places, but then modulus pi, which calls. So in C, what used to happen, you used to do a pointer, and then pointer used to point, the pointing variable used to point to the main variable. Likewise, you have here uh, defined pi variable, but then it is pointing to your original number, original variable. And you can use format.pi as well, but in this case, it will start from 0 and then two decimals after that 0. Yeah, same output in all these three cases, but just the different way of giving the output. Then you have with specifications. So ensure a minimum number of characters in or characters with colon nd, where n is width. So it is going to give number of characters. In this case, if you put 0, the blank characters till fifth point, and then you format it with 1. Yeah, this is somewhat less important. The more important is floating point formatting. This will come again. So mostly there are three methods to format a string. Sorry, a print. To format print statements, we have f string. Where we are just calling out x and y variables and then taking it to the original one. Then you have second syntax where you put curly braces and then you use dot format and all the variables to call. And then you have floating point like pointing variables where you have defined either d or f for integers and float respectively, and then you call your variables to finally print what you want. Here we have one example. I think this will be a good example. So we have a range starting from 1, 1, 2, 3, 4, 5. It's not taking the value 6. It's only going till 5. Okay. And then we have print f of I to d and I times I colon 3d. Okay. So what is happening here is we are doing this function. Where did it go? The d1, defining the width. So in 2D, okay, so we are making a matrix now. To make a matrix, you are calling the first one, which is 2D, so two column. Okay, so you have 3D through here, and you have 4D. Mm. Okay, okay, I get it. So in the first step, we are taking uh, one in all the values. So you have 1, 1, 1. Okay, and then you're doing 1 times 1, so that gives you the value of okay, yeah, it makes sense now. So you have three rows, three columns. So you have three values here. It will be a matrix. So in the first row you have 1, so you put 1 here. Then you have 1 times 1, again 1, 1 times 1 times 1, then again 1. And how many space you have? In first you have two space, then you have three space. So it's number of spaces you have. Then you have four space, 1, 2, 3, 4. So you have four spaces here. Likewise, in the next row, you have I is now 2. So because the I is 2, it will be 2, and then 2 times 2 is 4. 2 times 2 times 2 is 8. Then we have 3. 3 times 3 is 9. 3 times 3 times 3 is 27. Okay? If I run it, let's see. Yeah. Then it will be 4, then it will be 5. Taking all the values in this range, you will get uh, number of items. So in 27, let's see. In 27, how many spaces are there? You have 1, 2, 3, and fourth is this one. Okay? Okay. Yeah, it makes sense. Then you have currency. In currency, you have prices given, F and price, and you're pointing you want to place dollar before. So price, and you are taking two decimal places, so 99 will give you 49.99. Okay, makes sense. Then again, scientific notation. So then you have Avogadro's number, a very long number. Then you have Avogadro's number, and then you're taking two decimal places, so 0.2. Mm, Okay, hold on. Mm, Is it two decimal places? Oh, it's a two. Okay, two decimal place, but then it's E as well. So this part is not going anywhere. So when you say E, it is taking that E to the power of 23. But then you have two as well, so it's taking only two decimal places. Okay, yeah. So this was the various formatting that we had in this course. So next up, we have a problem statement. Uh, we are going to solve these problems using the concepts that we have learned before. So problem number 3 we have is day-wise total rainfall calculation. So objective here, the problem statement here is to calculate the total rainfall for each day over a given duration. For example, a week where each day's rainfall entries terminate with -1. Okay, so here we have defined. You're taking inputs from the user and storing that as an int value in days. Okay. For day in range, again, this day and this days are two different variables. You have to remember this. So day is calculating, is picking the numbers from this range. So the range starts from 1, days plus 1. Okay. So total equals 0, another variable defined, and the value given here is 0. Rainfall equals input, enter the rainfall. Okay. hmm So if you're again, you're taking users um, input saying enter the rainfall, and that is getting stored in rainfall. While, okay, so it's a nested loop. So the outside loop is a for loop, but the inside one is a while loop. So while rainfall is not equal to -1, total plus equals rainfall. So rainfall is not equal to -1. Okay, till there is no rain, total equals plus total becomes the rainfall, and rainfall takes another value, enter the rainfall. Okay, okay. Here is the confusion. Let me run this code. I think this is an important question, but I'm not getting the logic. Enter number of days. We have 30 days. Enter the rainfall. Okay, -1. Total rainfall for day 1 is 0. Enter the rainfall. 1, 1, 2, 3, -1. Okay. Hmm. The logic is making sense. Okay. For each day, what is happening here is we are counting number of days. You know what? Let me stop this and rerun this program. Hmm. Okay. Let me rerun. Number of days, I'm taking 5 as number of days. Total rainfall. Uh, okay. So we have devised a new method uh, to solve this question, and I'm going to explain every single line. So the first line you see here is days, input, enter the number of days. So we have two loops here. It's a nested loop. So the inner loop is counting the number of rainfalls that occur for the day. The outer loop is counting number of days. Okay. So first we have to determine how many days are there for the users to
count the rainfall. So we're taking input from the user, how many, so we want to know how many days are in the period. So let's take an example. I am typing 2 days. I only want to record the rainfall for 2 days only. Okay. So whatever I put as the input becomes integer value and stored in days. That's pretty straightforward. Then we have the outer loop. The outer loop is one iteration per day. So for day in range 1, days plus 1. So this is an important outer loop. What is happening here, we have a range first defined. Starts from 1, days plus 1. So if I put, let's say, 2 days, then becomes 1, 2, 3, but 3 is not calculated. So it's only calculating 1 and 2. The loop variable day will take each value of these values in turn. So it's choosing every single value from the range, and then everything indented under the line will run once per day. Okay, so this will run once, this will run once. So the first thing is we are initializing today's total. So what for loop is doing is it's running for day 1, day 2, day 3, and likewise how many days the user puts in. So initially we have to give total as 0. So at the start of each day, we set the total back to 0 so that yesterday's rainfall does not spill over to today's count. So that's why total here is 0. Then we have to read the first rainfall entry for today. So rainfall equals int input, enter the rainfall. So here the user puts the first rainfall calculation, how many times rainfall occurred. So it prompts the user to type the first rainfall measurement for the current day. The value is turned into an integer and stored in rainfall. Okay. And then we are running the loop again. Okay. Why are we running this loop? It's called a sentinel value. So what it does, it terminates the running of a loop. For example, while rainfall is not equal to -1, the total is going to be addition of rainfall. So rainfall value gets stored in total. Okay. And for example, total is 0, so the rainfall becomes 1. If I put 1, okay. So enter the rainfall, I put 1. And since it's not -1, it's going to run again. Now, if I put 2, see what happens. When I put 1, it takes the value rainfall, but it adds to the total, so it becomes 1. But then when I do put 2 here, it becomes 2 plus the original total, which was 1, so it becomes 3. Likewise, when I will put 4, it will store the 4 value. Okay. Now, what happens here is if rainfall is not -1, the body of while will run, and then we have total as accumulator initialized to 0, and it will store and increment every rainfall that is added by the user. And then another prompt appears so you can take their next measurement for the same day. And the loop continues until the user finally types -1, which is a sentinel value, meaning no more data for today. So let's say if I point -1, what happens? Rainfall is -1. So this loop gets over. So what happens now? We are taking string. String will show you the day. The day it will be 1 because we are taking the first value of the range. So in day 1, we are getting total rainfall of 7. It did the addition here. Okay, and that's why you are using 2 loops to run 2 different conditions. Uh, yeah. After the inner loop finishes, because -1 was entered, the program prints the grand total for the day, for that day. The placeholder day and total are filled in automatically by the f string, as you can see. The outer for loop now proceeds to the next value of day and then resets total to 0 and repeats everything. So day 1 was done, but if you remember, we put 2 here. So we are calculating the total rainfall accumulation for 2 days. We did it for day 1. Now we are doing it for day 2. So once this thing is printed, the for loop goes again to day 2, which is the final one here. And then we come back to total equals 0. Rainfall, we are taking the rainfall. The first rainfall is 3. And the total gets to 3. Then if I put 2, now the total will become 3 plus 2, which is 5. Then if I do 5, then total will take, and finally I put -1. That terminates. And on day 2, I am getting total answer as 10. So 10 rainfall points on day 2, and day 1, we only had 1 rainfall. The key point here is to remember that we have to loop control, make sure the uh, rainfall is terminating at some point. We are not just moving ahead and closing and just running the loop without any end. Okay, so this was the problem for the rain. Next, we will see the longest word length finder. So yeah, the next problem that we are going to solve here, the objective is to determine the length of the longest word in a set of user entered words terminated by -1. So whenever you see a terminated by -1, you should safely assume that you are going to use a while loop to satisfy this case. So let's go step by step. The first is this word board, which has max length defined to be 0. Now, the variable max length remembers the longest length seen so far, and we are starting with 0 because no words have been entered yet. Uh, and we are going to read the first word. The first word is taking the input here by the user, prompts the user for a word and stores it in word string variable. Okay. Now we have to run the loop, and especially run the loop. Excuse me. Run the loop until we get -1, which terminates the loop. So as long as the word you just typed is not the uh, sentinel -1, the indented block below runs. Okay, which means the code continues. And when you finally type -1, the loop ends and the program jumps to the final print. So we are going to measure the current word. So first up, we have current length, which is defined and stored in length word. So what length function is doing is calculating how many characters are there in the string. So, okay, and that is going to get stored in a new variable called current length. So length, again, length function uh, and taking an argument of word counts how many characters are in the word that you just entered. For example, it's not displayed, but when I'm putting a word chow, it's taking it is counting the length here, which is 4, and storing it in current length. Now, once the loop starts, you have calculated the length of the first word. Then you have to compare it to the original, right? And comparison it can only be possible using if statement. So next up, we have the if block right here. So if current length beats the previous record, so in the first example, we have max length set to 0. So obviously current length is going to win. So we did that, and we store if current length is greater than max length is going to become current length. In this case, current length is greater, so max length is not going to be 0 anymore. It's going to take the value of current length. Then the user, because -1 or the sentinel value has not been put by the user just yet, the program is going to run. Again, it's taking another word. The loop now goes back to the while condition and checks for a new word. So it checks a new word. Uh, Report the final results. So it does it again and again and again. I have given 5 different names here. You can see. Finally, what happens is the loop goes back to while, and it is going to print the length. So it is going to print the longest word, which is max length. And max length, the final max length or the highest will be the highest max length, right? Because after every iteration, what is happening is current length is getting stored in max length, and that's why max length will be the final number. So once the while loop gets terminated, the program leaves this block, this while loop block, and prints the final max length. That's it. That's the program. So after you type -1, the loop exits, and this line prints the longest length found. So I have given some examples here, and finally you see I got the longest word, which turns out to be this um, understandable word here. I just put the NEBS word here. So it has 8 characters and it is giving you 8 characters. Okay. So I think that is it. Mm, Okay, that's it. Yeah, that's the code. And next we are going to see break, continue, and pass. Next up we have break, continue, and pass. Statements in Python, you have seen this before. At least break, you have seen it in if statement. So these 3 control statements control loop execution in Python. Here's a clear breakdown of each. So we have break statement. Purpose immediately exit the entire loop when encountered. Use case terminate a loop early when a condition is met. Okay, so that's the purpose and that's the use case. We are going to see an example here. So we are taking an input from the client or the user, and the character in email. So character in the email means every single placeholder in that email list will be considered one after the other. So the first character, let's say first character equals at break. Exit the loop when at is found. So you are not you are only considering the first the username, not the anything beyond at. Okay, so you are printing car. You are printing that character. And okay, hold on. You're printing that character one after the other, and it's still in the loop. So let me just put here 00 at gmail.com so I can better explain what is happening here. So the first character is hero. H. Is H equal to at the rate? That's not possible, right? So break the loop and print the character. So you have just printed H.
and you are taking the end. Oh, okay. Do you remember this end? This was studied before as well, right? So it's a special type of formatting where the space is given. Okay, so what is happening here? H. Then you have, although I don't see space. Oh, hold on. What if I remove this? Hero0 at gmail.com. Oh, okay. Yeah, I see what is happening here. Uh, so I just forgot. Hero0 at gmail.com. So what is happening here? It's instead of printing every single character in new line, it's just putting all those characters in single line. So let's just take first one. H. H is not equal to at, so break the loop and print the character. But the loop, not break the if statement, not the loop. Loop is still on. So let's go to the second character, which is E. Is E equal to at the rate? No. So break, print E, and so on, so on. You go ahead, and finally you come to the character at the rate. Is at the rate equals at the rate? No. So break the loop. Oh, okay, yeah, yeah. So earlier, what was happening? If this was not true, then simply print. You don't have to put else, or you can, but if this is not true, it's going to print this. It's it's understandable. It's fine. It's pre-assumed understanding. If this is not true, then this print is going to happen. So you have H, okay, character, and okay, yeah, all right. So here's the thing: hero 0. It's starting from Hero. H is not equal to at. So you have H, then you have E, then you have RO and a 0. Okay, this is continuing. I hope this makes some sense. All right. So finally, when there was add a break, and then you left the loop. So this was the break statement. Let's continue with the continue statement. So purpose is to skip the current iteration and move to the next one. So we have seen this before as well. Break completely breaks the loop and leaves the code. This does not. This just leaves one iteration. That's it. It's still running the code. So let's take this example. Again, it's asking me to put the email ID I'm going to put, hero0 at gmail.com. Say you have for character in email. If char equals at the rate, print this, print a blank space, print a new line for domain. Okay, and continue. If character is not equal to at, continue, which means continue. So it's only going to print the at and whatever is in that command. So if I do it, gmail.com. So this is what is happening. What? So the first character, H in email, H equals at. No, that's not true. So it's continuing. Continue means the code is, this is going to get printed. Okay. This is not equal, right? If this is not equal, then this is going to print. So hero 0 is there. But as soon as we get at, character at is there, prints. Okay. So it's going to print a new line, and it is going to continue. It is skipping the at, and it is placing the new line. So it is not going to hold this value. So if character equals this, first of all, go to a new line, print the new line. You did that. Continue means you are not going to do this. You're not going to do this one. You're simply going to go to the next one, the next character, because you're skipping printing this character at. Okay, I hope this makes sense. Then we have pass statement. Pass, the purpose here is a null operation, does nothing. Used as a placeholder, use case, avoid syntax errors in empty code blocks. So we have one for loop here. So you have for I in range 11. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. If I modulus I of 3 gives you 0, so it's not going to give you for 1. It's not going to give you for 2. Is it going to give you for 2? No, not going to give you for 2. 3, yes. 4, no. 6, yes. 7, no. 8, no. 9, yes. So you have 9 of these numbers. So you have 0, 3, 6, 9, yes. So I equals print I else pass. Else pass means you're just going to do nothing for other numbers. So you have 0. 0 is this. 0 modulus 3 gives you 0. Yes, it does. So you're going to print 0. Let's take another example. 1. 1 modulus 3 gives you 0. No, that's not the case. So you are going to run else statement. If this is not true, else pass. Just pass it. Pass the number. Go to the next number. Next number is 2. So you're doing it for 2, 3, 6, 9. So you're only going to get the numbers 0, 3, 6, 9, which have the modulus remainder 0 when divided by 3. So key point here, without pass, Python would raise an error for empty else block. So you have to do pass if you want to remove and print only the remainder is 0. So your comparison table, break, continue, pass, very simple. Very interesting. So you have break, exit the loop entirely, continue, skips the next iteration, pass, does nothing. Yeah. Practical tips: break versus continue. Use break to exit a loop prematurely. Okay, that's simple. Use continue to skip specific iterations but keep looping. Break, exit the loop prematurely. You don't want, this was break statement right here. So you don't want to print this, right? So you break and printed the other. You could have used, you would say you could have used pass. But if I did pass, what would I get? Let's just check. Pass. Let's run it. So hero0 at gmail.com. Nothing is happening. It just did the pass. It exit the loop when zero is found. So it did, no, it did not exit the loop. It just passed. Okay, so it passed and moved to the print. So it's getting printed. When I do break, then things change. Yeah, it's exiting the loop and continuing with the rest. Okay. Uh, when to use pass? Temporarily ignore a block, for example, during development. Maintain syntactical correctness in empty loops function. Those are the two use cases of pass. Avoid infinite loops. You ensure break conditions are reached to prevent infinite loops. We are going to see some real world example to further strengthen our understanding of break and pass and other input commands. Thank you. We are going to see real world applications of these two statements, which are break, continue, and pass. So first, it's the use case of data validation. We have while true, user input equals input. Okay, so we are taking user's input. Okay, and when we do quit, we exit. So if user input dot lower gives you quit, then you break, exit the infinite loop. So while true, which means user is going to put the value. So if I put the value int, okay, it's not quitting, as you can see. It's running. The code is running. If I print no, again, this will keep on going. Okay, yeah, nothing happens. Same. Nope. Cool. Unless I put quit to exit, it's not going to exit. So if I put quit, let's do all caps. Yeah, the loop has been closed. The reason why is if user put the input value quit, break, simply break and exit the loop. The second example of using these statements is filtering data. We have a list of few numbers. So for num in numbers, starting from 1, 2, 3, 4, 5, 6, num equals 0 if this is equal to 0. Continue, print num. So what is going to happen? What do you think? So let's take example num1, 1 in numbers. Okay, the first number. Is it equal to 0? No, it's not. So print number, which is 1. 0, is it equal to 0? Yes, continue. Just skip the print command, but continue. 2, yep. Again, continue. 0, yep, continue. 3, oh, sorry, 0, continue. Yes, 2, print it. 3, print it. It was very straightforward. You can also print in the same line if you want by doing and this. If you remember here, end equals this, you can do this. End equals, yeah, I forgot. Let's do single brackets. Let's run it. 1, 2, 3. Again, very simple, straightforward. Placeholder in development. So we are defining a function. Okay, so it's using a function. Just you know what? Just ignore this part, the first line of code. Now we are going to see this later on. But simply remember that we are going to pass the command. So when we do it, it just passes this function and moves to another one. Okay, so this was so far the statements to break, continue, or pass a loop. Next, we are going to see basics of list. If you remember, list is a sequence type, sequence data type. And we had list, we had sets, we had dictionary. So all those numbers were there. We are coming back to list to see what we can perform. Okay, list is denoted by square break. It's very simple. It's ordered, mutable, can be changed, and can contain mixed data types. Let's run this. You will see numbers. Numbers is all numbers. Mixed, you have some numbers, some integers, some floats, some boolean. Everything is there. Common list operations we have. Okay, this is important. As we said, that lists are mutable, so which means you can add certain values to replace, insert, extend. So these are some of the actions which can be performed in a given list. So you have append adds to the end. We have nums dot append 6. So we 1, 2, 3, 4, 5, 6. Okay. Insert add adds at specific index nums insert 0, 0. Append is going to nums dot append. Where's nums? I am not seeing nums. Okay, let's just assume that nums is a range. Nums dot append 6. So you just add 1, 2, 3, 4, 5, 6. Nums dot enter 0, comma 0 adds to a specific index. 0, comma 0 means add 0 in zeroth place. So it's removing, it's just inserting, and rest all are shifted. Adds multiple items dot extend. So you are going to extend the list, which nums here. You just extended it to 6, carry 6 and 7 after 6. Then you have some other functions to remove, pop, clear. Remove first matching value. So nums dot remove 3. So 3 is gone. Pop means pop removes by index. So pop 0, it removes the zeroth place, not the place. It removes by the placeholder, not exactly the value itself. Clear, it just completely eliminates all the values inside. Okay, so we are going to see some example here. Um, okay, we have nums defined here. Nums dot sort. It sorts in descending order. So 3, 1, 4, 2 becomes 1, 2, 3, 4. You can also reverse it. So put reverse as true. It takes an argument, reverse equals true, and then it prints 4, 3, 2, 1. So these are some of the examples you have. Then we have nested lists. Again, nested lists becomes matrices. If you check very closely this list nums, you will identify that this is 1 cross 4 matrix. So lists of lists make matrix. So we have one example where we have lists of lists. So lists can contain other lists useful for matrices. So you have matrix 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. Okay. So it's list inside a list. Accessing elements. So you have print matrix 0, 0. It's taking 1. Then you have matrix 1, 2. What it is going to print. So it's going to print the first element, 1. Sorry, first row in this, second column. Oh, okay. I'm sorry. It starts from 0, 0, 0. Okay, my bad. So this is row. This is 1. This is 2. This is row. This is 1. This is row. This is 1. This is 2. So we are saying 1 and 2. 1, first row, 0, 1, 2, second column. So you have actually third column, but it starts from 0, so it becomes third here. So 1, 2 gives sixth value. This is how you can access uh, lists of list values. And then we have other useful list methods. We have length. So to get length, we have seen length before as well. That's not something new. Length will give 3. 1, 2, 3 dot index will give you the index value. So if you put 2 dot index 2, that will be 0, 1, 2. Oh, it's index takes 2. Okay, hold on. Oh, yes. So index of 2, second place, second value, or number 2 is taking first place. So 0, 1, 2. So it becomes first place. Then we have count occurrences. How many count is happening? So 1 is coming twice. So you have twice as a count. Then we have new equals old dot copy. So you have old dot copy create shallow copy. I am not sure what this is, but we will see. Reverse, again, very simple. Reverse, we did here, right? Sort reverse true. Give you the reverse value. You can also do it with the list as they did here. So 1, 2, 3 dot reverse will give you 3, 2, 1. So that's one. Again, slicing. One such example, slicing we have seen in the string, we are seeing it in our list. So you have nums defined, print 1, 4, 0, 1 till 4. So 1, 2, 3, 4, 4. So 1 to 4. 0, 1, 2, 1, 2, 3, 4. So you have 1, 2, 3 printed. Mm. And then when you do count or take the step, so it skips 2 steps. So 0 to 4, and then you do -1, it goes from the back. So 5, 4, 3, 2, 1, 0. So this was slicing. It's pretty simple. Then we have list comprehension. Comprehension, again, a very important one. So you have squares equals x exponentiation of 2 for x in range 5. Okay, this is a quite challenging one. You know what? Let me just skip this one for now. Run this. Um, hmm, hmm. Square x equals. No, why is it not printing anything? Anyways, you are taking x squared for x in range. So the output you will get is 0 will give 0, 1 will give 1, 2 will give 4, then 3 will give 9, 4 will give 16. And even for x in range 10, if x modulus gives this 2 equals 0. Simple, it's giving you the even number. So 0, 0 again. Yeah, this is 0. 1 not possible, so you skip that. 2, 4, 6, 8. Yeah, pretty straightforward, right? So let's to summarize, you have lists are ordered and they are mutable. Use append or remove for basic modification. Sort in reverse to modify the list in pace. Nested lists create multi-dimensional structures, and slicing provides powerful ways to extract sublists. So you have lists are fundamental to programming, Python programming. Master these operations to work efficiently with sequences of data. That's it. Now we are going to see some problems to brush up our concept and become very high. So we have two problems now based on the work that we did before. So the first one that we have is birthday paradox simulation. So we are going to demonstrate the probability that in a set of randomly chosen people represented by birthdays, at least two share the same birthday. Okay, so we are going to see the code and how it performs. Um, so we have a birthday paradox problem in and the first line of code is import random. So we are importing random modules to create random birthday. Why? So import function calls for the predefined libraries in Python. So these are designed to reduce the workload of the user and give them liberty to use these libraries to ease their work. Okay. So one such library is random, which generates random numbers, and it is going to give us the random birthdays. So we're creating an empty list because if we are going to uh, start for loop or any kind of loop, the first condition is to have the empty list. So we have defined L equals the empty list. And now we will fill the list with 60 random birthdays. So 60 random birthdays is for I in range 60, L dot append. So for I in range 60, so it's going to start from 0 to 59, L dot append random dot read int 1, 2, 3, 6, 5. So it generates 60 random birthdays. So and random.readInt is the function which produces integer between 1 to 365, ignoring the leap years. Leap years are 66, right? 366. And we are going to do this 60 times and push each number into the list. Okay, so this was the first part. And then we are going to sort it because we have to sort it. Any duplicate birthdays will be next to each other, making them easy to spot. And that's why we are going to sort these birthdays. We are going to print the sorted list finally, and to see if there could be multiple duplicates, right? Because you're generating random numbers, or maybe user also gave you random numbers. In those cases, you have to detect duplicates and remove them. So to do that, we are going to use while loop. While something is equal to that, then you are going to ignore it, right? So to make the while loop successful, we are going to use I equals 0, flag equals 0. So initialize I is the index as we walk through the list, and flag is the sentinel. Sentinel are those variables where if you put the value, it will stop the loop. So it's like a loop breaker. So 0, no duplicates found. 1, at least one duplicate found. So we're going to walk through the while loop here, the while loop to see what kind of code is this. So while I is less than the length L minus 1. So if Li equals Li plus 1. Okay. So while I is what? I 0. Length of L is the all the 60 numbers, but then you're doing minus 1, so you're taking one less. If Li or the first element of that list equals L1 plus 1, so Li is going to and the second number and the first number are same, then print repeats. Okay, and and then we are going to print repeat and then print both the numbers here, Li and Li plus 1. And then we are going to flag it as 1 and increment I with 1. So we compare every adjacent numbers, I and I plus 1. If they match, we announce the duplicates and set flag equals 1. I equals plus 1 moves up the next pair. If, let's say, flag equals 0, the last part of the code, then we are simply going to print there is no repetition. And if we never set flag to 1, the list had all unique birthdays. Okay. So I think this makes sense. We are going to run the code to see what type of output we are going to get here. It's still running. Okay. So it has generated 60 random numbers here. Okay. And we are going to see if there are any repeats adjacent to the numbers. So we have found that 94 and 94 there was a repeat, and that's the only repeat that there was. And then there it was another repeat, but it was in 216 and 216. Let's run this code again. And now we have found four repeats. So the first line, the four, it's going to append random number from starting from 1 to 365, all the dates, and then it's going to sort it. And probably this is the only thing that this for loop is going to do. In the next, we are checking. The first for loop is to generate numbers, random numbers, 16 random numbers, and append that to the list. And the second part here is to check if there are any repeats next to the code. So we are checking first place. Let's take an example here. So we have 288. So 0. The first position, ith, is going to start from 0. So 0 in length 1 minus 1 is length minus 1. So 0 is 1. 1 is is 0 greater than 0? No, that's not the case. So it's going to run and take this loop. No, sorry, it will go inside the loop. Then we have I taking the first one, 0. 0 equals to the zeroth position is the value is equal to the next position, which is li plus 1. If that's true, print repeats and then print both the value. Okay, that's done. And flag equals 0. Flag equals 1. Now we have I plus and equal to 1. So here what we are doing is we are taking the first value, I equals li plus 1. So we have 8 and 8. These two are same. The first one was not same, so 2 and 8 are not same, but the next position, 2 and third, are same. So we are going to print repeats and both the values, okay? And then flag is going to become 1. And I is going to get counted with 1. There's going to be an addition of 1 in the ith positions to move forward. So we are moving to the next pair, and flag is again 1. But let's say if we have completed all the codes, let's say if these two are not same, let's say if these two are not same, what we are going to do is the code is not going to print anything, and it is also not going to flag anything. It's just going to move to the next one, and then this cycle repeats until we hit uh, while what's the last position? Last position is 60th position. So we come to the very end, 60 and minus 1. So 60 minus 59, is 59 greater than 60? No, that's not true, right? We have hit the 60th position, but this is not true. So if if this is not true, it leaves the loop, and finally we come to flag equals 0. There is no repetition, and this is how the code finishes the execution. So why this matters? The birthday paradox illustrates how probability works counterintuitively. With just 23 people, there are 50% chance of shared birthdays. Okay. Next is naive search in a list. So here's it. So search for a user input number in a large randomly generated list, 1,000 elements. Okay, 10,000 elements. Next up, we have selection sort algorithm. So the obvious sort is another name for it. We are going to sort a list by repeatedly finding the minimum element and moving it to the new list. It's a sort of function or a problem where we are picking the numbers and minimum numbers and placing it in a new list. So let's break down this selection sort code step by step. The goal is to sort the list, which is 162, or this list stored in the value L, by repeatedly finding the smallest element and moving it to a new list. We have defined a new list, M, which is an empty list. So the original unsorted list is this one. This is unsorted, as you can see. Then we have a new list, an empty list right here. Now, main sorting is done here inside the while loop. So we are going to explain the loop. While L is not empty, okay, that's the first. The loop runs until all elements are moved to M. So even if there's anything which is greater than 0 will get passed through this code block. So while L is not empty, the loop runs until all elements are moved to M. Now find the minimum value. Start with min value as the first element of L right here. So min value
is the first element of L. Okay, we are going to iterate through every element in L using for loop. So inside the while loop, we are running the for loop. Okay, so we have selected a minimum value, and that minimum value is L equals 0. And then we are going to run the for loop, iterate through every element in L using for loop. And if an element is smaller than min value, update the min value. Okay, so we are for values there. If anything inside the list is less than minimum value, okay, minimum value is not defined anymore. Is not defined here. I mean, it's not predefined. Minimum value is whatever is there in the first position inside the while loop. So we have minimum value for loop. We are running it and seeing if the list element is less than minimum value, we are going to take then the minimum value is going to be that element, okay, and we are going to append the m list with the minimum value outside if loop, no, for loop. And L, we are going to remove L dot remove minimum value, and we are going to remove the minimum value as well. Okay. So loop. So once again, I'm going to explain this. While L is not empty, so the loop runs until all elements are moved to M. Okay. So if an element is smaller than minimum value, we are going to update minimum value, and we are going to append minimum value to M, which will be a sorted list, and remove minimum value from L, which is original list. So we are going to remove that value, the minimum value, and add it to the next one. So initial state, we have length, length of the code, no, length of the list, 1629 and so on. M. In the first iteration, what happens? Minimum value equals L0, which is 1. Okay, I'm running you through the code. So the initial value has a placeholder 1. So check all elements in L, all elements which are greater than or equal to 1. So minimum value remains 1 because nothing is greater than 1. And we are going to append L to M. So this is going to get appended in the first position, which is, so we m dot append minimum value. Minimum value is what? L0. Okay, so L0 value is getting stored in this. And likewise, we are removing L. So the new L is going to be 629 instead of 1629. If I do the second iteration, the first iteration we have seen 1 was the lowest. In the second iteration, we find that minimum value L0 is 6. So you have a new value 6. And we are going to check all elements in L. And we find 2 smaller than 6. So we are going to update minimum value to 2, and we are going to append that to the M list and remove 2 from the original list. Third iteration, same thing. We are going to do this activity again, repeat till the very end, and that's it. So how long it's going to run? Range is length of L, so it is going to run till the very end. The last value of, let's say, 854 will be left. So how is this going to run? 854 is greater 1, L0 is 1. Okay, is anything L0 is any minimum value? Minimum value is what? L is greater? No, it's not greater. So yeah, so if it's not greater, L0 value will be the last at the very end of this list, you will have L0 equals 854. So your minimum value, so your minimum value is going to be 854. Is 854 greater than 854? No, that's not going to happen. So this is it. This is how this program will run. Okay, hold on a minute. Okay, so in the very last, what is happening here? That's what I want to know. While length is greater than 0, it's not greater than 0. So it's not going to come if length is greater than 0. Oh yeah, it is greater. 1 is greater. Okay. So minimum value will be this one, 854. We're going to print 1, 2, 5, 6, 8, 9. Okay. So it is going to print all the values and remove the last one. So in this list, nothing will be left. Okay. We can use sort as well. If we do dot sort, it's going to sort everything. But again, if we use loops, then it gives us better practice in solving problems. So Another mathematical concept that we have in statistics is called dot product of vectors. So we have to compute the sum of products of corresponding elements in two lists. Okay, so let's see how we can solve this problem. Okay, so we have the same list, if I suppose. Okay, yeah. X has 9 elements, and Y also has nine elements. We have two lists with 9 elements. Length is matching, so code can proceed. There will be no errors. So first, we have to check if length equals length Y. In short, vectors are same length. Both vectors have 9 length, so condition is true. We are going ahead with the program. Dot product is 0. If we have initialized dot product as a 0, and loop through elements for I in range len x. So for I in range length of x, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. We have 9. I in range 9. So there are 8 elements for I in range. Okay. Dot product is what? It's the is addition equals to xi times yi. So the first element and the second element gets added, and the dot product is basically the addition of all the products of the two items. Okay, so I will explain. The loop runs for I from 0 to 8. Okay, so that's why for loop is there. Dot product is, so for example, let's focus on I6th value. I6 is 0, 1, 2, 3, 4, 5, 6 is 854. I'm just taking an example. Y6 is again 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 85. So we have 854 and 85. We are going to multiply that using this for loop. Okay, Y6 value is getting multiplied, and we got an answer as, let's say, suppose we get some answer. That is going to get added to your original dot product. We started as which actually started as 0. It's not 0 anymore. It's 72, I think, something value after multiplying 854 and 885. So this was it for the value. So for example, let's take all index 0. We have 1 and 342. So product is 342. The next element has product 6 and 5. That's 30. Then 61 and 2, it's 122. Likewise, we get all the products. It gets added, and you get the final sum of the products, which becomes your dot product. But you are actually adding it here only. So you have 342 plus 1. Yet another program that we have for to understand mathematical concept of matrices can be solved using Python. So let's break down this code step by step to understand how to add three times three matrices element wise. Okay, so let's first define the matrix here. We have A and B. It's basically lists of lists. So you have 1, 2, 3, comma 4, 5, 6, comma 7, 8, 9. So it's 3 cross 3 matrix. Likewise, we have B elements given here. Okay. Matrix A and matrix B are defined as lists of lists. It's a 2D list. So each inner list represents a row. For example, row 0 of A is 1, 2, 3. Row 1 of B is 9, 8, 5. Okay. Initialize the result matrix. So initializing the result matrix is going to be matrix C. So matrix C is a 3 cross 3 matrix with zeros. Okay, again, it's predefined. So this is a 3 cross 3 matrix, but with all the elements as 0. It's called identity matrix. Not exactly identity. It's an empty matrix, but still, you get the point that all the elements are 0. This will store the sum of A and B. Okay. You need to have some understanding of matrix to really solve this question. Your high school mathematics should have taught you how to do multiplication or addition of matrix. So when you have 3 cross 3 matrix, adding another 3 cross 3 matrix, it's possible. Okay, for I in range 3. Okay, so I in range 3, so 0, 1, 2. Okay, for J in range 3, so again 0, 1, 2. So we're taking the first element in I. So we have outer loop and we have inner loop. So outer loop iterates over row 0 to 2. Inner loop iterates over columns 0 to 2. Okay. So I and J is defined. I is defined before and J is defined later. So it's basically a counter. So 0, 1, 2, 0, 1, 2. That's it. Okay. So you are going to get inside the 0th row for 0 in range 3. For J in range 3 column. And okay, for each position ij, it adds the corresponding elements from A, B, and stores the result in C. So what's the first I? Is 0, right? 0 in range 3. What's the first j? It's j. Okay. So this the outer loop is going to get stuck at 0 until all the elements in 3 in j are first covered. So that's how you know it's going to do the first row first. Okay. So I in range 3, j in range 3, cij. It's taking the value ci. So c0 and j0. C0 and J0 is going to give you 0, 0. So what is 0, 0 position? It's here. It's right here. So you have 0 row and 0 column. That is going to be this. Equals to A1, AI, and AJ. In this case, it's going to be A0 and 0. So A0, 0 row, and 0 column. It's going to be this one. Plus B0, B0, and 0. So 2 plus 1, 3. Then what this program is going to do is it's not coming out of the 0 column. It's still staying in the same column. It's just going to change j. So I is still 0, j becomes 1. So j becomes 0 and j becomes 1. So this position, this value, likewise this loops continues. So once all the j gets completed in 3, so 0, 1, 2 is done, it is going to go back to I and then the next row, which is 2. So it's a row-wise addition which is happening. And finally, you get the output. So for example, if you have to print the result, here's how the values are calculated. So row 0 will be 1 plus 2, 3, 2 plus 5, 7, and 3 plus 1, 4. This will be the first calculation because we are still inside the inner loop. And that gives you the result 374 for C matrix. Then after we finish the first row, which is row 0, we go to row 1, which is I equals 1. And that's when you get 13, 13, 11. And then you do the second row, you do the final and last row, which is third, and then you get the answer 12, 11, and 15. So subsequent number of rows are calculated, one after the other. So it's a 2D matrix, and you are using nested loops and element-wise operations is being performed here. I hope this makes sense. We have time complexity value, not important right now, but yeah, we are going to see time complexity later on. Next concept we have is understanding matrix. Like we have seen for Python matrix addition, the next step is matrix multiplication. So this is the formula that is every single row gets multiplied to the column of the other matrix, and that's how you define the third matrix. This is the formula. You can see it. Let's see the implementation in Python. So to perform matrix multiplication, we have 3 cross 3 matrix. Again, this is suitable. We have matrix A and matrix B are defined as 3 cross 3 lists of lists. Row 0 of A is 1, 2, 3. Column 0 of B is 2, 9, 8. And these two are going to get multiplied to get the first element of C. Now, what is C? C is, again, 0 matrix, an empty null matrix of 3 cross 3 size. This will store the product of A and B. So first, we have matrix multiplication logic here. So you are using 3 loops inside. So we have outer loop, middle loop, and inner loops. So what outer loops does is iterates over row of matrix. So 0, 1, 2. So pretty simple. In addition, we have seen this. In addition, there was J loop, which is now the middle loop. There it was the inner loop. So what it did was finding the column values in the column. And then we added those 2 values to find the addition. But in matrix multiplication, you have to take another inner loop, K. What it does is it computes the dot product. So summation of dot products will give you the matrix value of matrix product value, right? So inner loop, which is K here, computes the dot product of ith row of A and jth column of B, which is so what it is doing is it is giving you the product of A, I, and K. Okay, so that's the ith row. And the J column is giving you the value of BKJ. Okay, accumulation will give you the C. So how this matrix multiplication is happening? So first row and first column. So what is the first element of row 1? So it's 1 and 2. So 1 times 2, that's the first element. The second element is going to be 2 times 9. Okay. Again, I'm sorry, not the second element. The summation of all these will give you the first element. So 2 times 1 plus 2 times 9 plus 3 times 8. So we have 3 here and 8 here.
So this will be the first value of C. If you print it, you will get the matrix multiplication. So just remember, outer loop, it's triple nested. So outer loop selects the row from A. The middle loop selects column. Middle loop J selects column from B, and inner loop K computes the dot product by iterating or through elements of the selected column. Okay. You have to also make sure order matters. So matrix multiplication is not commutative. So A times B is not equal to B times A. It's yeah. So you have to remember the order, how you place. Yeah, that's it. Another important topic that we have now is basic function structure. So we have seen loops, we have seen conditional statements, data types, and all the relevant information that we needed to learn. Now we are coming into the advanced stuff, which is functions. So we will see first. Let's see how the functional function is defined, and then we will see what's the use of function. So definition of function, function name, and function takes parameters, and then we have function's body and function returns something. So it's a code block that does one thing and one thing. Well, it can do multiple things, but here it's doing one action based out of the context. So it's a context dependent code block which does something for a particular case. So that's a function, and you can call function again and again. So it's reusable. For example, you have defined add a comma b. So a comma b, a is the value of it is taking just a parameter. So add is a function, and we know function is taking an argument. This is all we know. Next up, inside the function, what you are doing is you have one function block where you have defined the variable ans equals a plus b. The argument which is inside add is getting added here, and finally you print to get the answers. We have set parameters, so you have a and b, action add a and b, output we are receiving. Now, what's the difference between return and print? So print displays output to console. So whatever you print will be displayed on the console and user can see it. Return, however, gives back the value to the caller. So here we are printing something. We are not returning, but let's say in future we will see return functions as well, where we are taking a value, but we are returning it to the user. Okay. Print cannot be used in further calculations. Print is simple. Print just gives you. Return is a value given by which acts as an output of a function. That's why the return can be called, and it can allows chaining operations. So multiple things can be done. Example here we have def add print ab, and then we have add print. Add print you can give two parameters here, 2, 3. So this is the definition of function. A function is defined here. So add prints will take two arguments, and we are going to print a plus b. Now, when we call this function and give the parameters, you don't have to do print as such. It is going to give you 5. You don't have to do any addition print because the print is inside the definition itself. So all you have to do is print. You print the number, and you get the total equals add print 2, 3 plus 10. Hmm. Okay. Yeah, I think this makes sense. So you have total here equals add print 2, 3 plus 10. So add print 2, 3, 2 plus 3 is 5, plus 10 will give you the total value. Again, this gives you an error, okay? And we will see why. We will see why because this is printing something. Again, you can't add this. It's not returning the value, it's simply printing, doing what is defined here. That's why when you do this, your total is not going to be 15. It gives you an error. You have to return the output to be used again in future. So define add return a and b, a comma b. When you do return a b, this gives you the value now. So when you do add return 2, 3 plus 10, this works and gives you the total value, which is 15. I've run the command. Let's see what we get. So again, we got the answer wrong in the first case. So you have 5 and 5, but then we got the error. Okay. Yeah, this is the error. So with return, it's reusable. Without return, it's not usable. Let's comment this out in all the program. Oh shit, sorry. Okay, we are going to run this. It's returning, but it's not printing. So what we have to do is probably print total. Okay, yeah, 15. Now, when you return this, you get 5, but then it gets added to 10. That becomes 15.
I hope this makes sense. Okay. Next up, we have practical function examples. So you have subtraction function, define def sub a comma b. Answer is a minus b. Print answer. That's the definition of a function for subtraction. When we are doing define discount, cost is the first parameter. Second parameter is d. Answer is going to be cost minus cost times discount, which is d over 100, and then you are going to return the ans. And final price is where you will use this returned ans output to discount. When you call this discount the 100 comma 20, it is going to do the discount. You can actually see it once I run the final price output. Final price, yeah, 80%. 80 is the new dollar value that you have. I hope this makes sense. Okay, again, this as well we can discuss. Calling function with user input. So we have defined a previous program. Again, we have reused the program. So you have defined the discount cost and d. Return cost minus cost times d over 100. So that's a return value. X, we are taking input from the customer. Y, we are taking the discount from the customer. And then we are calling to check the final output. It's pretty simple. 100 discount is going to be 20%. You are going to get 80%. So this is another way of solving and doing programming using functions. I think this is more suitable, and this is how professional coding is done. So use a function will come handy later on. Why use function? So one thing is reusability. Write once, use often. So as I said, it for a given context, it gives you the result which can be used again and again. Modularity. So modularity. So the modularity break code into logical blocks. You can do that. Okay, so for example, for if we create a function for addition, we can make a modular code which gives you the result, and then we have debugging, isolate, and fix issues in specific function. We can do that as well. And then we have definition. So define function a comma b, create reusable code, return a plus b, pass results to other code, print a plus b, displays the output, and these are the parameters. This is all you have to uh, learn here. Next up, you have accessing list elements. So if you define a function first element and you give the parameter as list, and then return list 0. So list first element is list, and then you're taking the first input of the list. This is what it is returning. So let's say we have defined x, which turns out to be a list. So if we print first element x, in x, what it is going to give you the output? It's going to give you the 0th placeholder, which is 1. So output is going to be 1. Yeah. Likewise, we have minimum, maximum values, combining lists, append list before, after other, calculate average. Okay, then we are doing okay. You know what? I will come back to these problems and solve this again. But before, let's do some hard problems in functions to give better learning for us. These will be the hardcore problems. Okay, let's do that.